different kinds of errors or exceptions. For example, right after we get the age, let's define a variable income and set it to 20,000. And then define another variable called risk and set it to income divided by age. Let's run this program and enter 0 as the age to see what happens. So 0 is obviously a numerical value. So when we enter this value, technically we shouldn't get any exceptions. Take a look. Our program crashed with a 0 division error because we cannot divide a number by 0. Once again, look at the exit code. So we couldn't catch this kind of error or this kind of exception with this except block. This except block is only catching exceptions of type value error. And this happens when we try to convert a non-numerical value to an integer. So in a situation like this, we should handle different kinds of exceptions. We can add another except statement for an exception of type 0 division error. Now in this block, we can print a different kind of message like age cannot be 0. Let's run our program one more time. Now I'm going to enter 0 as the age. So we get this error message, age cannot be 0. And look at the exit code. It's 0, so our program didn't crash. So to recap, we use try except blocks to handle exceptions that are raised in our programs. As a good programmer, you should always anticipate these kind of exceptions and handle them properly. In this tutorial, I'm going to talk to you guys about comments in Python. We use comments to add notes or comments to our programs. For example, here I'm going to make a print statement. Sky is blue. Now, before that, I can add a comment using a hash sign, and then whatever I type here is going to get ignored. It's not going to get executed. Let me show you. So let's run this program. Look, we only see this message, sky is blue. So with this comment, we can explain something about our code. We can use that as reminders to fix things or clean things up, or we can use it to communicate things with other developers reading our code. Why we have written this code in a certain way. These are good use cases for using comments. We can also have comments over multiple lines, so we can simply add more comments. Each line should start with a new hash sign. Now, one thing you need to avoid when using comments is explaining what the code does. So here's an example of a bad comment. Let me just delete these 2 lines. And with this comment, I'm going to say print sky is blue. Why is this a bad comment? Because it's telling me the obvious. It is obvious that the next line is going to print sky is blue. Now, the problem with this comment is that apart from being verbose and repetitive, if we come back here and change sky to ocean, now this comment gets outdated. So every time we change this code, then we'll have to come back and modify the corresponding comment. So I've seen some developers add comments in front of their functions. For example, they define a function, let's say square, that takes a number and simply returns number times number. Well, it is obvious that this function calculates and returns the square of the given number. So there is really no need to add a comment and explain that. Calculates and returns the square of a number. This is very repetitive and it creates noise in your code. Someone else reading your code, they get distracted with all these unnecessary comments. So use comments to explain whys and hows, not whats. If you have made certain assumptions, you can use comments to explain those assumptions, or you can use them to add notes to remind yourself or other developers to do something in the code. So comments are good, but too much of a good thing is a bad thing. In this tutorial, I'm going to talk to you guys about classes in Python. Classes are extremely important in programming and they're not specific to Python. In fact, a lot of other programming languages do support the notion of classes. We use classes to define new types. For example, so far, you have learned about the basic types in Python like numbers, strings, and booleans. These are the basic or simple types in Python. You also learn about a couple of complex types like lists and dictionaries. While these types are extremely useful, they cannot always be used to model complex concepts. For example, think of the concept of a point or a shopping cart. A shopping cart is not a Boolean. It's not a list. It's not a dictionary. It's a different kind of thing. So we can use classes to define new types to model real concepts. Now, in this tutorial, I'm going to show you how to define a new type called point. And this new type is going to have methods for working with points. For example, back to our main program, let's create a list, numbers, 1, 2, 3. You know that here, when we type dot, we get access to these functions or methods available in list objects. Now, similar to this, we're going to create a new type called point. This point is going to have methods like move, draw, get, distance from another point. These are the operations that we can perform on points. So let me show you how to do this. We start by defining a class using the class keyword. And right after that, we give our class a name. Now look at the naming convention I have used here. I've capitalized the first letter here. This is what we call Pascal naming convention. So the convention we use for naming our classes is different from the convention we use for naming our variables and functions. For variables and functions, we always use lowercase letters, and we separate multiple words using an underscore. But when naming classes, we don't use an underscore to separate multiple words. Instead, we capitalize the first letter of every word. So in this case, our class has only a single word. If it had multiple words, let's say email client, look, I've capitalized the first letter of every word. Once again, this is called Pascal naming convention, and it comes from the old Pascal language that you might have heard of. So back to our point class. Here we add a colon, which means we're going to define a block. Now in this block, we can define all the functions or methods that belong to points. For example, we can define a function called move for moving a point. Now note that as soon as we type open parentheses, PyCharm automatically adds self here. This is a special keyword, and we're going to get back to this shortly. So for now, in this method, let's print move on the terminal. Now let's define another method like draw. So define draw. And in this method, let's print draw on the terminal. Now let's remove the indentation. We're done with the definition of our point class. So we need to add 2 line breaks. Okay. So with this class, we defined a new type. With this new type, we can create new objects. So an object is an instance of a class. A class simply defines the blueprint or the template for creating objects, and objects are the actual instances based on that blueprint. So we could have tens or hundreds of points on the screen. These are the objects or the instances. So to create an object, we type out the name of our class and then call it like a function. This creates a new object and then returns it. So we can store that object in a variable. Let's call that point1. There you go. Now when we use the dot operator, look, we have these 2 methods that we defined, draw and move. We also have a bunch of other methods that start with 2 underscores. These are called magic methods. We'll look at them later in the course. So now let's call the draw method of our point object and run our program. So you can see draw is printed on the terminal. Now, apart from methods, these objects can also have attributes, and these attributes are like variables that belong to a particular object. For example, here, after we define point1, we can set point1.x to 10 and point1.y to 20. Now we can easily print out these attributes. Let's print point1.x and run our program one more time. Take a look. So the x coordinate of point1 is 10. Now we can create another object. Let's call that point2. So point2, once again, we type out the name of our class and then call it like a function. Now this object is completely different from the first object. So if we print point2.x, look, we get this attribute error because this point object doesn't have an attribute called x. So each object is a different instance of our point class. Now here we can assign a value to point2.x. Let's set that to 1 and then run our program. So we can see the x coordinate of point2 is 1. So to recap, we use classes to define new types. These types can have methods that we define in the body of the class, and they can also have attributes that we can set anywhere in our programs. You have learned how to create new types using classes. Now, there is a tiny problem in this implementation. We can create a point object without an x or y coordinates. Let me show you. So point, we create this object here. And before we set point.x, let's print point.x. Run our program. We get this attribute error that you saw in the last tutorial. So point object has no attribute called x. This is the problem we have here. It is possible to have a point object without an x or y coordinates. And that doesn't really make sense because whenever we talk about a point, we need to know where that point is located. To solve this problem, we use a constructor. A constructor is a function that gets called at the time of creating an object. So here on line 9, when creating this point object, we want to pass values for x and y coordinates, let's say 10 and 20. And with this point object that we get here will have its x and y coordinates initialized. So how do we do this? We need to add a special method in this class called constructor. So on the top, we define a new function. Look at the name of this function, $init $. So init is short for initialize. And this is the function or the method that gets called when we create a new point object. Now, press enter. So this automatically adds self in parentheses. We're going to come back to this shortly. Now, right after self, we want to add two extra parameters, x and y. So let's type out x and y. And then in the body of this method, we should read the values passed here and use them to initialize our object. So when we pass 10 and 20, these arguments will be used for x and y parameters. Now to initialize our object, we type out code like this, self.x equals x, and then self.y equals y. What is going on here? This self that you see here is a reference to the current object. So back to line 13, when we create a new point object, self references that object in memory, the same object that we are referencing using this variable. So earlier we typed point.x equals 10. With this code, we set the x attribute of this point object. Now what we have in the constructor is exactly the same. We're using self to reference the current object, and then we set the x attribute to the x argument passed to this function. So using this init method, we can initialize our objects, and we refer to this method as a constructor. This method is used to construct or create an object. Okay, so now let's remove line 14. So we create a point object with these values and then print point.x. Let's run our program. There you go. X is 10. We can also change these values later. So just before printing point.x, we can set point.x to 11 and then run our program. So x is updated. Beautiful. All right, here's an exercise for you. I want you to define a new type called person. These person objects should have a name attribute as well as a talk method. This is a very easy exercise, so you can tackle it in probably a couple of minutes. All right, so first we start with the class keyword. We define this person class. Once again, look at the naming convention I have used here. The first letter of the first word, in this case, the only word, is uppercase. Now, in this class, we define all the methods that we need. Currently, we have only one method, that is the talk method. So define talk. PyCharm automatically adds self. We come back to this shortly. For now, let's just print talk. So this is the body of our person class. We remove the indentation and add two line breaks after defining our classes. Now we can create a person object. Let's call that John. We set it to person. We can call John.talk. Let's run the program. So we get this message, beautiful. But our person objects should also have a name attribute. It doesn't make sense to have a person without a name. So that is when we use the constructor function. So on the top, we add a new method. The name of this method is double underscore init double underscore. So we call this method a constructor. Now, in this method, we need to add another parameter that is name. So we simply set self.name to name. Once again, self references the current object. So we're setting the name attribute of the current object to the name argument passed to this method. With this, we can go back to line 9. And when creating a person object, we pass the name. Let's say John Smith. Now let's print john.name and run our program. There you go. So John Smith is printed on the terminal. Beautiful. So this is all you had to do as part of this exercise. But let's make this program a little bit more interesting. Instead of printing this boring message here, let's print, "Hi, I am John Smith." So we can use a formatted string with a message like, "Hi, I am." Now we want to dynamically add the name of this person. How do we do that? Well, look at the parameter of this talk method. As I told you before, every method in our class should have this parameter, self. And this should be the very first parameter of every method, okay? So with this self, we can get reference to the current object. So we can add curly braces and type out self.name. This returns the name attribute of the current person object. With this, we can remove line 10, where we print john.name, and simply call john.talk. Let's run our program. "Hi, I am John Smith." Beautiful. Now we can create another person object. Let's say Bob is a new person called Bob Smith. When we say bob.talk and run our program, we get a different message. "Hi, I'm Bob Smith." So each object is a different instance of a person class. In this tutorial, I'm going to talk to you guys about inheritance in Python. Inheritance is a mechanism for reusing code. And once again, it's not limited to Python. Most languages that support classes also support inheritance. So let me show you how it works. Let's say we have this dog class with a simple walk method. In this method, we're simply printing the walk message on the terminal. Now, let's say in a real program, instead of just one line of code here, we're going to have 10 lines of code. Now, what if in the future we want to define another class, let's say cat, and we want to add this walk method there as well? We'll have to repeat all that code in this new class, walk. This is bad because we have repeated or duplicated our code. In programming, we have a principle called DRY, which is short for don't repeat yourself. And here's the reason. Let's say sometime in the future, we discover a problem in our walk method. If we have repeated or duplicated this method in many other places, then we'll have to come back and fix that problem in every single place we have duplicated this code. So that's why in programming, we should not define something twice. So how can we solve this problem? Well, there are different approaches. One approach, which is easier to understand for beginners, is inheritance. And here's how it works. We define a new class called Mammal and move the walk method right there. Then we'll have the dog and cat classes inherit that method from their parent, just like how humans inherit certain attributes or behaviors from their parents. It's exactly the same. So on the top, we define a new class. Let's call it Mammal. Then we need to move the walk method there. So we select it, cut it using Command and X on Mac or Control X on Windows. And then paste it here. Beautiful. Now we want our dog class to inherit this method from the Mammal class. So right after the class name, we add parentheses and then type out the name of the parent class. In this case, Mammal. That's all we had to do. So with this, the dog class will inherit all the methods defined in the Mammal class. Now there's a tiny problem here. If you look at line 9, there is a red underline here. The reason this is happening is because Python doesn't like an empty class. So right now, our dog class is empty. It doesn't have anything. We either need to add methods specific to dogs, or just to make Python happy, we can use the pass statement, and that basically means nothing. We're telling Python interpreter, hey, pass this line, don't worry about it. But with this, we don't have an empty class, okay? Now, as I told you before, after each class, you should have 2 line breaks. So right now we only have 1 line break, and that is the reason we have this little warning here. So let's add another blank line. Beautiful. So our dog class is inheriting the walk method from the mammal. We need to apply the same change to the cat class. So we'll have cat inherit from mammal, and then we use the pass statement here. With these changes, now we can create either a dog or a cat object. Let's say dog1, we set it to a dog object. And when we type dot, look, we have the walk method that is defined in the mammal class. We can easily call it. Let's run our program. There you go. We see the walk message. So both the dog and cat classes are inheriting all the methods defined in their parent class. Now here we can add methods specific to dogs. For example, we can define a method called bark and then print bark. Now we don't need the pass statement because we already defined one method in our dog class. So now when we type out dog1 dot, look, we have 2 methods. One is the walk method that we inherited and the bark method that we just defined in the dog class. Similarly, we can add a method specific to a cat. For example, we can define a method called be annoying. Yeah, I hate cats. So let's print annoying. Now, when we create a cat object, let's remove that, cat1, and type out cat1 dot, we have these 2 methods, walk and be annoying. So these are the basics of inheritance in Python. Now, there's more to this that really goes beyond the scope of this beginner's tutorial. If you're interested to learn more about inheritance and other mechanisms for reusing code, I encourage you to get my complete Python course. In this tutorial, I'm going to talk to you guys about modules in Python. A module in Python is basically a file with some Python code. And we use modules to organize our code into multiple files, just like sections in a supermarket. When you go to a supermarket, there are different sections for fruits, vegetables, cleaning products, and so on. We don't have one section with all the products in the supermarket. We have the same concept in programming. So instead of writing all of our code, instead of writing all the functions and classes in app.py, we want to break up our code into multiple files. We refer to each file as a module. With this, not only is our code better organized and structured, but we'll also have the ability to reuse our code. For example, over here in app.py, I've defined 2 functions for converting weight from pounds to kilograms and vice versa. Now we can take these 2 functions and put them in a separate module called converters. And then we can import that module into any program that needs these converter functions. Let me show you how to do this. So let's open up our project panel and right-click the project, go to new and add a new file. We're going to call this file converters.py. Then we go back to app.py, select all this code, cut it, and then paste it into our new module, converters.py. With this, we have cleaned up our app module. It's not bloated with different functions. So as we write more functions and classes, we put them in their corresponding modules. A module should contain all the related functions and classes. Okay. Now, you want to import the converters module into our app module, and that is really easy. On the top, we write import converters without the extension. So we don't add .py. We only type out the name of the file. Let me close the project panel. Now, this converters is an object, so we can use the dot operator to access its members. So currently we have defined these 2 functions inside of our module, kilogram to pounds and pounds to kilogram. So we can easily call one of these functions. Let's pass 70 kilos, get the result and print it out. Run our program. So that is 155 pounds. Now there is also another syntax for importing modules. Let me show you. So instead of importing the entire module, we can import specific functions from that module. Here's how it works. We type out from, then we add the name of our module, so converters, import. Now here, if you press Control and space, you can see the list of all the functions defined in this module. So here we can grab one of these functions, let's say kilogram to pound. And with this, we can directly call this function just like a function defined in this file, app.py. Compare what we have on line 4 with what we have on line 6. On line 6, we'll have to prefix this function call with the name of an object, converters. So we have to type converters dot, and then we'll be able to access this function. In contrast, when we import a specific function from our module, then we can easily call that function without prefixing it with the module name. So here's what you need to take away. We use modules to better organize our code. Instead of writing all the code, instead of writing all our functions in one file, we break up our code across multiple files. Each file is called a module, and it should contain all the related functions and classes. Then we can import a module into another module. In this case, we are importing the converters module into our app module. And as you saw, there are two ways to import a module. We can import the entire module, and then we'll get an object with the same name as the module. So we can type converters dot, and then we'll be able to access all the functions and classes defined in this module. The other approach is to import a specific function or class from a module using the from import statement. Now here's your exercise. Earlier in the course, we had an exercise for finding the largest number in the list. So here on the top, we have a list of numbers. Initially, we set max to the first number in this list. Then we loop through this list, get each number. If the current number is greater than max, then we reset max. And finally, when we're done with our loop, we print max on the terminal. Now here's what I want you to do. This code currently has no organization. We don't have any functions. We don't have any modules. We wrote all the code in app.py. And that is okay for small programs, but as your programs grow, you need to properly organize your code into functions, classes, and modules. So as part of this exercise, I want you to write a function, call it find max. This function should take a list and return the largest number in that list. Now, after you do this, go ahead and put this function in a separate module. So extract it from here and put it in a module called utils. So in this module, we're going to have a bunch of utility functions, okay? Then import the utils module into the current module and call this function. Finally, get the result and print it on the terminal. This is a fantastic exercise to teach you how to properly organize your code. So go ahead and spend a couple of minutes on this exercise. So the first step is to define a function called find max. So on the top, I'm going to define a function, find max. This function should take a list of numbers. So we add a parameter called numbers. Now inside of this function, we want to have these few lines. This is the algorithm for finding the largest number in a list. We don't want to bring the first line because this is where we create a list. So somewhere in our program, we're going to create this list and then pass it as an argument to find max function. Okay, so let's go ahead and grab these few lines, cut them, and put them inside of find max function. All right, so we find the largest number in this list. Finally, we need to return it. So return max. So here's our function. Now we need to move this into a separate module. So let's go to the project panel, right-click the project, and add a new file. We can also add a new Python file. It's the same. Let's call that utils. So if you add a new Python file, PyCharm automatically adds .py extension. But if you go to new file, we'll have to explicitly type out .py. So make sure to get the extension right. Now, back to app.py. Let's cut this code and paste it into this new module. Okay, beautiful. Now we go back to app.py and import our new module. We can either import the entire module, so import utils, and then access individual functions. So we can call utils.findMax, or we can explicitly import this function from the utils module. It doesn't really make a difference. So we could type from utils, import, find max. And then we don't need to prefix this with the name of its object. So we simply call find max. Now we need to call this after we initialize our list. So first we need to define the list of numbers. Then We pass that list as an argument to find max. We get the result, which is max, and finally we print it on the terminal. Let's go ahead and run our program. So the largest number in this list is 10. Beautiful. Now, one last thing before we finish this tutorial. Here we have this little warning under max, and the tooltip says shadows built-in name max. The reason we see this is because in Python, we actually have a function called max, and it does the exact same job as our find max function. So this is actually built into Python. But I ask you to do it as an exercise because it's a great exercise for beginners. Now, back to the warning. This warning is basically telling us that we are overwriting the built-in max function in Python. So we're changing the meaning of this function, and this is considered a bad practice. Let me show you what I mean. So let's comment out what we have on line 4. By putting a hash sign here, we can also use a shortcut, command and slash on Mac, or control and slash on Windows. So now this line is commented out. Look at the color of max here. It's purple. It's the same color as print. And this is the color used to identify the built-in functions. So now we can call this function and give it our list of numbers, run our program, we get the exact same result. However, if we bring this line back, once again, we can use the same shortcut, that is command and slash on Mac or control slash on Windows. Now we are redefining max. So up to this line, max used to be a function, but after line 4 is executed, max is set to an integer. That is the largest number in this list. So we'll no longer be able to call it on line 5. Let's run our program and see what happens. So there you go. We get this type error. Int object is not callable because max is now an integer. It's not a function, so we cannot call it. So to solve this problem, we can rename this variable to something else. So right click here, go to refactor and rename this to maximum. So you can see the warning is gone. Also, we have the same warning in our utils module. So here we're redefining max. And as I told you before, this is a bad practice. We're changing the meaning of built-in functions in Python. So let's rename this as well. I'm going to use the shortcut that is Shift and F6. There you go. And here we can change this to maximum. Enter, done. In this tutorial, we're going to talk about packages in Python. Packages are basically another way to organize our code. So currently we have only 3 files or 3 modules in our project, but a real project can contain hundreds or even thousands of modules. We don't want to add all those modules here because over time, this directory will get bloated with so many files. So a better approach is to organize related modules inside of a package. So a package is a container for multiple modules. In file system terms, a package is a directory or folder. So in our project, we can add a new directory, and in that directory, we can add all the related modules. As a metaphor, think of a mall. When you go to a mall or a shopping center, there are different sections for men's, women's, and kids' clothing. So that is like a package. Now, when you go to the men's section, there are different areas for different kinds of products. We have a section for shoes, t-shirts, jackets, and so on. So each of these is like a module. So in this tutorial, I'm going to show you how to create and use packages in Python. Here in our project panel, right-click the project and add a new directory. Let's call this directory e-commerce. So we're going to create a package called e-commerce. And in this package, we're going to have all the modules related for an e-commerce application. For example, we can have modules for sales, shipping, customer service, and so on. So let's go ahead. Now, here we have an empty directory. In order to convert this to a package, we need to add a special file in it. So right-click this directory and add a new Python file. Call that file _init . This is a special convention in Python. When Python interpreter sees a file with this name in a directory, it treats this directory as a package. We also have a shortcut for that in PyCharm. So let me delete this directory and start again. So delete. Once again, right-click the project and go to new. But instead of creating a new directory, we can create a new Python package. Let's call our package e-commerce. As you can see, PyCharm automatically creates this file for us, so we don't have to manually create it. Okay. Now, in this package, let's add a new module. So a new Python file. Let's call it shipping. Okay. Now in this module, we want to add a function for calculating the shipping cost. So define calculate underline shipping. And don't worry about parameters or the implementation. We simply print calculate underline shipping. Now let's say we want to import this shipping module into our app module. With this new structure, this shipping module is now part of the e-commerce package. So we cannot import it directly. We have to start from the e-commerce package. Okay. So back to app.py. Once again, there are two ways to import this module. We can import the entire module, or we can import one of its functions or classes. So let me show you both approaches. First, we're going to import the entire module. Import. Now, what is the name of our package? That is e-commerce, right? So e-commerce dot shipping. So instead of typing import shipping, we type import e-commerce dot shipping. We have to prefix it with the name of its package. Now to access any of the functions or classes in this module, we'll have to type out e-commerce.shipping dot, and there you go. Now we can access the calculate shipping function. So let's go ahead and run our program. We see this message printed on the terminal. Beautiful. However, with this approach, every time we want to call one of the functions in this module, we'll have to prefix it with e-commerce dot shipping dot. That is very verbose. So when working with packages, we often use the second approach using the from statement. So we can type from e-commerce.shipping import calculate shipping. Now we don't have to prefix this function with e-commerce.shipping, and we can call it multiple times in this module. So our code is a little bit shorter. But what if you want to use multiple functions in this shipping module? We can either import them all here, so calculate shipping, comma, let's say calculate underline tax, or we can import the entire module and then access all the functions or classes in that module. So let me revert this back. To import the entire module, we type from e-commerce, so we remove dot shipping. So from this package, import the shipping module. Now this shipping module is an object, so we can access all the functions and classes defined here using the dot operator. So shipping dot, there you go, calculate shipping. So to recap, when using the from statement, we can either start from the package and import a specific module, or we can start from package dot module and then import a specific function, like calculate shipping. So this was the basics of using packages in Python. As I told you before, packages are extremely important, especially when you want to work with a framework like Django. We use Django for building web applications with Python, and I'm going to show you that later in this course. So in Django, we have quite a few packages, and each package contains several modules. So make sure to watch the tutorials about modules and packages one more time. Otherwise, you're going to get confused later when we get to Django. In this tutorial, I'm going to talk to you guys about the built-in modules in Python. So Python comes with a standard library that contains several modules for common tasks such as sending emails, working with date and time, generating random values and passwords, and so on. There are so many modules already built into Python, and that means there is already lots of functionality that we can reuse. We don't have to code all of that from scratch. Let me show you where you can find this standard library. So open up your browser and search for Python 3 module index. Make sure to add the version number because the modules in Python 2 are different from modules in Python 3. So here we search for Python 3 module index, and the first page here, you can see it's Python module index for Python 3. Let's go ahead. So these are all the modules built into Python. For example, we have modules for working with date and time. We have modules for sending emails, for encoding values. There are so many modules here. Now, the explanation of all this is beyond the scope of this course. That really requires its own course because we have so many modules here. But don't let this list intimidate you. This is not something that you need to learn right now. As you work with Python, as you build more applications, gradually you will get more familiar with various modules here. In fact, nobody knows all the modules in Python standard library. Everybody knows some modules based on the applications they have built. So in this tutorial, I'm going to show you how to use one of the built-in modules for generating random values. So on the top, we import the random module. Now, because random is a built-in module, we don't need to have a file here called random.py. So Python interpreter knows that random is a built-in module and it knows where to find it. Now, if you're curious where this random module is stored on the disk, let me show you. So here in the project panel, expand external libraries, then expand Python 3, and then one more time, Python 3.7 library root. So this is a folder somewhere on your computer. In this folder, we have all the built-in modules in Python. So if you scroll down, you should be able to find the random module. There you go. It's right here. So random.py. You can open this and this shows you the source code of this module. There you go. Now in this tutorial, we don't want to worry about that. So let's go back to our app.py and use this module to generate random values. So when we import this module, now we have this object random. So we can use the dot operator to access its methods. One method that is very useful here is the random method. And every time we call it, it generates a random value between 0 to 1. So here we can do a for loop. Let's say for I in range 3. So just to refresh our memory, we are using the range function to create a range object. We can loop through this range object, and in each iteration, this object will spit out a value. So with this for loop, we can execute this code 3 times. Now let's indent this. Okay. And finally, let's print the result. There you go. So we can see that in each iteration, we get a new random value between 0 to 1. Now, what if we want a random value for a particular age? Let's say random values between 10 to 20. Well, there is another method here, randint. We pass 2 arguments here to specify our range. Let's say 10 and 20. Run our program one more time. Now we have the numbers 20, 13, and 18. If we run our program one more time, we get different values. So 20, 19, 11, one more time. Look. We also have another powerful method for randomly picking an item from a list. Let's say we have a list of team members and we want to randomly pick someone as the leader. Let me show you how to do that. So we define the list of team members. We set it to John, Mary, Bob, and Mosh. Now we can call random the choice and pass our members list. This method randomly picks an item from this list and returns it. So we can store the result in leader and then print it on the terminal. Let's run our program. So now the leader is Mary. If we run our program one more time, this time it's Mosh. Now it's Mosh again, one more time. It really likes Mosh. Now it's Bob. You got the point. So the random module is very powerful and it has a lot of applications. Now here's a very cool exercise. I want you to write this program to roll a dice. So every time we run this program, we get different values. Now we have 3 and 1. Next time we get 3 and 6. One more time, 5 and 6, 4 and 3, double 1. That's a very cool exercise. So before we get started, I want you to pay attention to a few things. I want you to define a class called dice. In this class, we're going to have a method called roll. So every time we call this method, we get a tuple. A tuple, remember, is a list of values, but that list cannot be changed. We cannot add a new item to it. We cannot remove it. So it's like a read-only list. So every time we call the roll method, we should get a tuple of 2 random values. So go ahead and do this exercise. You'll see my solution next. All right, we start by importing the random module on the top. Then we define a class called dice, colon. In this class, we want to have a method called roll. So define roll, parenthesis, this automatically adds self. Now in this method, we want to generate two random values between 1 to 6. So we call random.randint and pass 1 and 6. So this generates the first number. We can put that here. Now let's call this one more time. So I'm going to copy what we have on line 5, put it here, and change this variable to second. So we have two variables, first and second, with two random values. Finally, we need to return them in a tuple. So return parentheses instead of square brackets, first and second. Now in Python, when you want to return a tuple from a function, you don't have to add these parentheses. So you can simplify your code and Python will automatically interpret this as a tuple. Okay? So we're done with the definition of our class. We remove the indentation and add two line breaks. Now we create an object of this type. So we set dice to dice. Next, we roll the dice, so dice.roll, and print the result on the terminal. That's all you had to do. Let's run this program. So now we get 2 and 5. Let's run it one more time. 3 and 2, 1 and 1. Beautiful. Now we have this little warning here that says expected 2 blank lines, found 1. Once again, this is coming from PEP 8. PEP is short for Python Enhancement Proposal. We have so many Python enhancement proposals or PEPs. PEP 8 is a very famous one. And in this document, we have all the best practices for formatting our code. So PEP 8 says that after we define our classes, we should have 2 line breaks. We already done that. So the reason this is complaining is because we have 1 line break before the class. So let's add 1 more line break. Now PyCharm is happy. So basically PyCharm is following all the best practices defined in PEP 8. Now you don't have to memorize any of these best practices. As you code in PyCharm, PyCharm gives you little warnings and gradually you will learn how to properly format your code so it's readable by other people. In this tutorial, I'm going to show you how to work with directories in Python. So here on Python 3 module index, you can see we have a module called pathlib, which provides an object-oriented file system path. That basically means it provides classes that we can use to create objects to work with directories and files. So if you click here, you can see how this module works. You can see all kinds of examples. For example, here under basic usage, you can see this is how we import the path class from the pathlib module. Let me zoom in so you can see clearly. Okay, so look, from pathlib, that's our module, import path. Note the naming convention. P is capitalized. That means path is a class. So we need to create an instance of this class, as you can see right here. Now there is so much documentation here. You can read this on your own, but let me quickly show you a few examples to help you get started. So back in PyCharm, on the top, from the pathlib module, let's import the path class. Now we need to create a path object to reference a file or a directory on our computer. So there are basically 2 ways to do this. We can use an absolute path or a relative path, which basically means a path starting from the current directory. For example, if you want to reference this e-commerce directory in our project, we can use the relative path. So we start from the current directory and then go somewhere else. With absolute paths, we start from the root of our hard disk. For example, if you're on Windows, you might have an absolute path like this: C drive / program files / Microsoft. So these are directories in C drive. On Windows, we use a / to build a path. If you're on Mac or Linux, your paths look a little bit different. So instead of a /, we have a /. Let's say user/local/bin. So these are examples of absolute paths. In this tutorial, we're going to work with a relative path to work with this e-commerce directory that we have in our project. Now, if you didn't create this directory earlier, simply right-click on the project and then go to New Directory. Okay, so let's close this panel. We create a path object. Now, if we don't pass an argument here, this will reference the current directory. Alternatively, we can pass a string. In this string, we can add a file or a directory. Let's say the e-commerce directory. Now this returns a path object, so we store it here. Now this path object has a few interesting methods. For example, we can check to see if a path exists by calling the exists method. This simply returns a Boolean, so let's print it on the terminal. There you go. So this path exists, but if we change this to, let's say, e-commerce1 and run our program, we get false. We can also create a new directory. For example, let's change this path to emails. Now, when we run this program, obviously we don't have this directory, but we can create it by calling the mkdir method. So make directory. Let's run our program. All right. This method returns none, which basically means it doesn't return any values. Now, if you look at the project panel, you can see here we have a new directory called emails. We can also delete this directory. So instead of mkdir, we call rmdir, which is short for remove directory. Let's go ahead. Now you can see that directory is gone. We can also find all the files and directories in a given path. That is very useful if you want to write a little program to automate something. For example, you can iterate over all the spreadsheets in a directory, open them, and process them. Let me show you. So first we change the path to the current directory, and then we call the glob method. With this method, we can search for files and directories in the current path. So as the first argument, we need to pass a string that defines a search pattern. We can type an asterisk, and that means everything, all files and all directories. We can optionally add an extension. So to get all the files, we use star. With this pattern, we'll only get the files in the current directory, but not the directories. We can also search for all the Py files or all the Excel spreadsheets, anything. So let's search for all the Py files in the current directory. Now, when we run our program, we get this generator object. Generator objects are kind of an advanced topic, and they are beyond the scope of this beginner's Python course. But for now, all you need to know is that we can iterate or loop through these generator objects. So instead of printing this generator object, let's just iterate over it using a for loop. So for file in the generator object that is returned from the glob method, let's print file. Run our program. There you go. So these are all the Py files in my current directory. This could be different on your machine if you didn't follow the exercises I gave you earlier. For example, this utils.py, we created this as part of one of the exercises earlier in this course. So don't worry if the files you see here are different on your machine. So we can use the glob method to search for files using a pattern. We can also get all the files and directories in the current path. So we just use one asterisk, run our program, take a look. So we have this e-commerce directory. We have notes.txt. This is a file I added earlier just to write notes as part of my presentation. So you're not going to have this file. We also have a bunch of other directories and files. Even though Python's standard library is very comprehensive and has so many modules for common tasks, it's not complete by any means. That's why we have this directory called Python Package Index or PyPI. And in this directory, you can find thousands of packages for doing awesome things. These are the packages that people like you and I have built as part of their projects, and then they published it in this directory for other people to use. So that's why we have a fantastic community in Python. There are so many Python developers out there, and there's so many packages right in front of us to reuse in our programs. Let's say you want to send text messages in your programs. You don't have to build this functionality from scratch. You can simply come to pypi.org and search for SMS. As you can see, there are so many projects or packages that give you this functionality. Of course, not every package, not every project is complete or bug-free. Some of them are still in development or they have bugs. But if you look around, I'm pretty sure for any kind of functionality you can imagine, there is a good, reliable, and well-documented package for you. In my complete Python course, I will show you some of the most useful packages on PyPI. For example, you will learn how to access the information on Yelp.com in your programs. So you can write a program and search for businesses registered on Yelp. Let's say you want to search for the best barbers in New York City. I will show you how to do that. You also learn about a technique called web scraping, which means you can build an engine and have that engine browse a website and extract information from HTML files. This is the same technique that Google does to index various websites. So they have several engines or web crawlers. These crawlers are continuously looking at various websites and extracting information from their pages. When you publish a blog post, Google's web crawler finds the title of your post, its keywords, and so on. So I'm going to show you how to do that with Python. We'll also look at browser automation, and this is extremely powerful because you can automate testing of your web applications. So you might get a job as a test engineer, and your daily job is to browse a website, click here and there, fill out this form, that form, and ensure that the website is functioning properly. You can automate all of that with a powerful Python package called Selenium, as I have shown in my complete Python course. Now, in this tutorial, I'm going to show you how to install packages from pypi.org. So here on pypi.org, let's search for OpenPyXL. This is a package that we use for working with Excel spreadsheets. So let's search for this package. There you go. So currently it's at version 2.5. On the top, you can see this instruction, pip install OpenPyXL. This is the command that we need to type into a terminal window to install this package into our program. So back to PyCharm. Here on the status bar, we can open up a terminal window for executing various commands. So let's open it. Now, if you're on Windows, you're probably going to see something different instead of this $sign. Don't worry about that. Just execute this command I'm going to show you. So pip install OpenPyXL. Make sure to spell everything properly. So pip is the tool that comes with Python installation, and we use it to install or uninstall packages registered on pypi.org. So here we're using pip to install this package, OpenPyXL. Enter. Let's go ahead with that. It's going to take a few seconds. Okay, done. Now we can import this package and its modules, just like the built-in modules in Python or the modules that we have in our project. Now, if you're curious where this package is stored on disk, let me show you. So open up the project panel and then expand external libraries. Next, expand Python 3 and then expand site packages. This is where all these packages that we install with pip are stored. So here we have OpenPyXL. You can open this. In this folder, we have another folder called cell. Now, look what we have here. We have this init py. Earlier, I told you that whenever we add this file to a folder, Python treats that folder as a package. So cell is a package, and in this package, we have these modules, cell, interface, read-only, and text. So as you can see, this package, OpenPyXL, has several sub-packages like cell, chart, chart sheet, and so on. And in each package, we have several modules. In the next tutorial, I will show you how to work with Excel files. So we have covered all the core concepts in Python. I hope you learned a lot. Please support my hard work by liking this video and sharing it with others. And be sure to subscribe to my channel for more tutorials like this. Next, we're going to work on our first Python project that involves automation. You're going to write a Python program that can process thousands of spreadsheets in under a second. Are you excited? Let's get started. In this tutorial, I'm going to show you something really awesome you can do with Python. You're going to learn how to process spreadsheets. And this is extremely valuable in situations where you have hundreds or thousands of spreadsheets that need to be updated. If you want to do this by hand, it may take hours, days, weeks, or even months. You can simply build a Python program in less than half an hour and have that Python program automatically process thousands of spreadsheets in under 1 second. So here we're going to work on this Excel spreadsheet. You can download this below this video. In this spreadsheet, we have 3 columns: transaction ID, product ID, and price. Now, don't worry about the 4th column yet. So in this spreadsheet, we record all kinds of transactions, but let's say due to an error, it could be a human error or a system error, the price that we have here is wrong. Let's say we need to decrease this by 10%. If you want to do this manually, we'll have to come back here and add a formula. So we type out equal sign. Let's say we want to recalculate the value of this cell, that is C2. So we'll have to get that and then multiply it by 0.9. So that is like the 90% of the original price. We are reducing the price by 10%. Now when we hit enter, you can see the updated price. Next, we'll have to come back here, select the cell, and then apply the same formula to all the other rows. Now, what if we have thousands of rows here? We'll have to scroll up and down. This is going to be very tedious. So we're going to write a Python program that will do this for us. It's going to automate this process. And not only that, it will also add this beautiful chart right here. Once again, if you want to open up hundreds or thousands of spreadsheets and add a chart to each one, this is going to take at least a week or two. Our Python program is going to do all of this in a matter of seconds. So let's get started. All right, the first thing I want you to do is to download this transactions file and add it to your project. I'll put the link below this video for you to download. So if you're wondering how to put this in this project, you can simply right-click the project. And if you're on Mac, you have this item, Reveal in Finder. If you're on Windows, you should see something like Reveal in Explorer or File Explorer or Windows Explorer. Whatever it's called, when you click this, this opens up the directory on your machine where this project is stored. So you can simply copy and paste the transactions file right here. Now, here on the top, first we need to import the OpenPy Excel package. So import OpenPy Excel. We can give it an alias to make our code shorter. So as Excel. This is not required, but it just makes our code a little bit cleaner. Let me show you. So now instead of typing OpenPy Excel dot, we type XL dot. Okay, so that's an alias for this package. Now in this package, we have a function for loading an Excel workbook. So let's call load workbook. And as the argument, we pass transactions.xlsx. So this will load our Excel workbook and return a workbook object. Okay. Now, if you open this workbook, you can see you have only one sheet, and that is called sheet 1. So to access that, we use square brackets and specify the name of the sheet. That is sheet 1. Make sure to spell this with a capital S because this is case sensitive. If you don't spell it properly, you're going to get an error. So this returns our first sheet. Now in this sheet, we have various cells. So next you need to learn how to access a particular cell. And that is very easy. Back to PyCharm. With this sheet object, we can use square brackets and give the coordinate of a cell. The coordinate is the combination of the column and the row. For example, this cell, its coordinate is A1. So back to PyCharm, here we can type A1 and this returns our first cell. There is also another approach to get a cell. Instead of using square brackets with a string, we can use the cell method of the sheet object. So sheet.cell, we pass the row and the column. So row 1 and column 1. This returns the exact same cell. Now let's print the value of this cell. So cell.value and run our program. So the value is transaction ID. Beautiful. So now we need to iterate over all these rows. And for each row, we need to get the value in the third column. That is the price. We'll get that and then multiply it by 0.9. So first we need to know how many rows we have in this spreadsheet. We can get that from the sheet object. So sheet has an attribute called max_row. Let's print this. So in this sheet, we have 4 rows and you can verify that here. So we have a total of 4 rows. So we need to add a for loop that would generate the numbers 1 to 4. So let's delete this print statement and add a for loop for row in. We're going to use the range function to generate a range of numbers starting from 1 all the way to sheet.max_row plus 1. The reason we're adding 1 to this is because, as I told you before, this range function would generate numbers starting from this value all the way to this value, but it will not include the second value. So currently max row returns 4. If we use range of 1 to 4, this will generate the numbers 1, 2, and 3, but not 4. So to include 4, we need to add 1 to it. Let's go back here. So we type sheet.max_row plus 1. Now before going any further, let's just print row and make sure our program is working up to this point. So let's run this. We get the numbers 1 to 4. Beautiful. So now we can easily get the cells in the third column. However, we don't really want this first cell, that's the heading. So technically, we want to ignore the first row. Back here, we want to change our range function and start from 2. Okay? Now, we're going to use sheet.cell to get access to the cell at this row, and the column should be 3. We get a cell object. Let's print its value and make sure we're on the right track. So run our program. These are the values we get: 5.95, 6.95, and 7.95. These are the values in the third column. Beautiful. Next, we need to multiply each value by 0.9. So instead of printing cell.value, we multiply it by 0.9. And this is the corrected underlying price. So this is the mistake we're going to fix with our program. Now we need to add a new cell to our worksheet. So we want to add all the corrected prices in a new column. We could also overwrite the values in this column, but in this tutorial, I'm going to show you how to add a new column. So using the same method, now we need to get a reference to the cell in the given row, but in the fourth column. So we call sheet.cell and pass row and 4 as the arguments. Once again, this returns a cell object. Let's store that in a separate variable and call it corrected underline price underline cell. So note that my variable names are very descriptive. There is no guesswork. We have corrected price, which holds the actual value, and we have corrected price cell, which is a cell object in this spreadsheet. Next, we need to set the value for this cell. So we set corrected price cell dot value to this corrected price. With these few lines, we can easily update our spreadsheet. But first, we need to save it. So after our for loop, we call workbook.save. Now let's save this in a new file. So we don't want to accidentally overwrite the original file in case our program has a bug. So I'm going to call that transactions2.xlsx. Now finally, let's run our program. So you can see that happened in a split of a second. Now here we have a new file, transactions2. When we open this, we get something like this. So you can see we have this fourth column with the updated prices. Beautiful. So half of the problem is solved. Now we need to add a chart here. To add a chart, we need to import a couple of classes on the top. So after this import statement, let's type out from openpyxl.chart import bar chart, comma, reference. So let's see what's going on here. In this package, we have a module called chart. And from this module, we're importing 2 classes, bar chart and reference. Again, look at the naming convention used here. The first letter of every word is capitalized. Also, it's better to add a line break after our import statements to make our code cleaner. So before we save our workbook, we need to add a chart to the current sheet. First, we need to select a range of values. For this exercise, I'm going to select the values in the fourth column. So all the values in rows 2 to 4. These are the values I'm going to use in our chart. Now, in this particular example, it doesn't really make sense to add a chart per transaction, but that doesn't really matter. We just want a bunch of numbers to create a chart. So after our for loop, we're going to use the reference class to select a range of values. Now, the first argument in the constructor is the sheet. So we pass our sheet here. Then we add 4 keyword arguments. The first one is min underline row. We set this to 2. The second one is max underline row. We set this to the maximum row in this sheet. That is sheet.max underline row. So we want to select the cells in row 2 to 4. Okay. Now to make this code a little bit cleaner, I'm going to put this on a new line so you can see clearly. Now this is going to select all the cells in all the columns in these rows. That's not what we want. We only want the values in the fourth column. So back here, we need to set a couple more keyword arguments. Min underline col or column, we set that to 4. And also max underline col, we set that to 4 as well. So we're limiting the range of cells we're selecting to the fourth column. Okay. Now we're creating an instance of the reference class. Let's store the result in a variable called values. So this values object will have all these values in the fourth column. Now we're ready to create a chart. So we create an instance of the bar chart class and store it in this object. Next, we call chart.add underline data, and pass our values. That is pretty straightforward. Finally, we need to add this chart to our sheet. So we call sheet.add underline chart and pass this chart object. We should also specify where we want to add this chart. Let's say we want to add it here on row 2 after the 4th column. So the coordinate of this cell is E2, and this is going to be the top left corner of our chart. So as the coordinate, I'm going to pass E2. That's all we had to do. Done. Let's run our program one more time. Beautiful. Let's open up the updated workbook. And here's the end result. So right after the 4th column, we have this beautiful chart. Now we could take this to the next level. We could add a legend here. We could change the color of these bars. We could even use a different kind of chart. It doesn't have to be a bar chart. So to learn more about this, you can read the documentation for OpenPyXL. So our program is complete, but our code is dirty. It's not clean. It's not organized. We don't have any functions here. We have written all the code in app.py. So let's go ahead and organize this code like a professional software developer. So on line 4, we're loading our workbook. Then we're getting a reference to the first sheet. But we don't really need these 2 lines here. This was purely for demonstration to show you how you can access a cell. So let's delete these unnecessary lines. This is a very important practice. As you're coding, always look at your code, always review it. See if you have some code that is not used. Always delete those. Okay, next we're iterating over all the rows, fixing the prices, and then we select these values to add a chart, and finally we save the workbook. Now, if we were going to use this to automate the process of updating thousands of spreadsheets, this program wouldn't work because it's only relying on this file. So we want to reorganize this code and move it inside of a function. This function should take the name of the file as an input. So let's define a function. Let's call it process underline workbook. It gets a file name. Now we move all the code inside of this function. So let's select everything and then press tab. Beautiful. Now back to our function. Instead of loading this transactions file, we're going to load this file name. That's better. Also, now that our program is working properly, there's really no need to store the result in a separate file. So here we can simply overwrite the same file. So let's pass file name. That is the end of our function. So now we have this reusable function. We can simply reuse this to process thousands of spreadsheets. Earlier in this Python course, you learned how to find all the files in a directory. So you can get each file in a directory and pass the name of the file to this function. This function will go ahead and update that spreadsheet in just a second or less. So that was just one example of using Python to automate repetitive, boring tasks that waste your time. But automation is not just about processing Excel spreadsheets. There are so many things we can automate. Here's a question for you. What do you want to automate? How do you want to use Python to make your life easier? Use the comment box below and let me know. I love to hear about your ideas. Next, we're going to work on a project that involves machine learning, which is a subset of artificial intelligence. Are you excited? Let's get started. In this section, you're going to learn about machine learning, which is a subset of AI or artificial intelligence. It's one of the trending topics in the world these days, and it's going to have a lot of applications in the future. Here's an example. Imagine I ask you to write a program to scan an image and tell if it's a cat or a dog. If you want to build this program using traditional programming techniques, your program is going to get overly complex. You will have to come up with lots of rules to look for specific curves, edges, and colors in an image to tell if it's a cat or a dog. But if I give you a black and white photo, your rules may not work. They may break. Then you'll have to rewrite them. Or I may give you a picture of a cat or a dog from a different angle that you did not predict before. So solving this problem using traditional programming techniques is going to get overly complex or sometimes impossible. Now, to make the matter worse, what if in the future I ask you to extend this program such that it supports 3 kinds of animals: cats, dogs, and horses? Once again, you'll have to rewrite all those rules. That's not going to work. So machine learning is a technique to solve these kind of problems. And this is how it works. We build a model or an engine and give it lots and lots of data. For example, we give it thousands or tens of thousands of pictures of cats and dogs. Our model will then find and learn patterns in the input data So we can give it a new picture of a cat that it hasn't seen before and ask it, is it a cat or a dog or a horse? And it will tell us with a certain level of accuracy. The more input data we give it, the more accurate our model is going to be. So that was a very basic example. But machine learning has other applications in self-driving cars, robotics, language processing, vision processing, forecasting things like stock market trends and the weather, games, and so on. So that's the basic idea about machine learning. Next, we'll look at machine learning in action. A machine learning project involves a number of steps. The first step is to import our data, which often comes in the form of a CSV file. You might have a database with lots of data. We can simply export that data and store it in a CSV file for the purpose of our machine learning project. So we import our data. Next, we need to clean it. And this involves tasks such as removing duplicated data. If we have duplicates in the data, we don't want to feed this to our model because otherwise our model will learn bad patterns in the data and it will produce the wrong result. So we should make sure that our input data is in a good and clean shape. If there are data that is irrelevant, we should remove them. If they're duplicated or incomplete, we can remove or modify them. If our data is text-based, like the name of countries or genres of music or cats and dogs, we need to convert them to numerical values. So this step really depends on the kind of data we're working with. Every project is different. Now that we have a clean data set, we need to split it into two segments, one for training our model and the other for testing it to make sure that our model produces the right result. For example, if you have 1,000 pictures of cats and dogs, we can reserve 80% for training and the other 20% for testing. The next step is to create a model, and this involves selecting an algorithm to analyze the data. There's so many different machine learning algorithms out there, such as decision trees, neural networks, and so on. Each algorithm has pros and cons in terms of accuracy and performance. So the algorithm you choose depends on the kind of problem you're trying to solve and your input data. Now, the good news is that we don't have to explicitly program an algorithm. There are libraries out there that provide these algorithms. One of the most popular ones, which we're going to look at in this tutorial, is scikit-learn. So we build a model using an algorithm. Next, we need to train our model. So we feed it our training data. Our model will then look for the patterns in the data. So next, we can ask it to make predictions. Back to our example of cats and dogs, we can ask our model, is this a cat or a dog? And our model will make a prediction. Now, the prediction is not always accurate. In fact, when you start out, it's very likely that your predictions are inaccurate. So we need to evaluate the predictions and measure their accuracy. Then we need to get back to our model and either select a different algorithm that is going to produce a more accurate result for the kind of problem we're trying to solve, or fine-tune the parameters of our model. So each algorithm has parameters that we can modify to optimize the accuracy. So these are the high-level steps that you follow in a machine learning project. Next, we'll look at the libraries and tools for machine learning. In this lecture, we're going to look at the popular Python libraries that we use in machine learning projects. The first one is NumPy, which provides a multi-dimensional array. Very, very popular library. The second one is Pandas, which is a data analysis library that provides a concept called data frame. A data frame is a two-dimensional data structure similar to an Excel spreadsheet. So we have rows and columns. We can select data in a row or a column or a range of rows and columns. Again, very, very popular in machine learning and data science projects. The third library is Matplotlib, which is a two-dimensional plotting library for creating graphs and plots. The next library is scikit-learn, which is one of the most popular machine learning libraries that provides all these common algorithms like decision trees, neural networks, and so on. Now, when working with machine learning projects, we use an environment called Jupyter for writing our code. Technically, we can still use VS Code or any other code editors, but these editors are not ideal for machine learning projects because we frequently need to inspect the data, and that is really hard in environments like VS Code and Terminal. If you're working with a table of 10 or 20 columns, visualizing this data in a terminal window is really, really difficult and messy. So that's why we use Jupyter. It makes it really easy to inspect our data. Now, to install Jupyter, we're going to use a platform called Anaconda. So head over to anaconda.com/download. On this page, you can download Anaconda distribution for your operating system. So we have distributions for Windows, Mac, and Linux. So let's go ahead and install Anaconda for Python 3.7. Download. All right, so here's Anaconda downloaded on my machine. Let's double click this. All right, first it's going to run a program to determine if the software can be installed. So let's continue. And once again, continue. Pretty easy. Continue one more time. I agree with the license agreement. Okay. You can use the default installation location, so don't worry about that. Just click install. Give it a few seconds. Now, the beautiful thing about Anaconda is that it will install Jupyter, as well as all those popular data science libraries like NumPy, Pandas, and so on. So we don't have to manually install this using pip. All right, now as part of the next step, Anaconda is suggesting to install Microsoft VS Code. We already have this on our machine, so we don't have to install it. We can go with continue and close the installation. Now, finally, we can move this to trash because we don't need this installer in the future. All right, now open up a terminal window and type Jupyter with a Y space notebook. This will start the notebook server on your machine. So enter. There you go. This will start the notebook server on your machine. You can see these default messages here. Don't worry about them. Now it automatically opens a browser window pointing to localhost port 8888. This is what we call Jupyter Dashboard. On this dashboard, we have a few tabs. The first tab is the Files tab. And by default, this points to your home directory. So every user on your machine has a home directory. This is my home directory on Mac. You can see here we have a desktop folder as well as documents, downloads, and so on. On your machine, you're going to see different folders. So somewhere on your machine, you need to create a Jupyter notebook. I'm going to go to desktop. Here's my desktop. I don't have anything here. And then click new. I want to create a notebook for Python 3. In this notebook, we can write Python code and execute it line by line. We can easily visualize our data, as you will see over the next few videos. So let's go ahead with this. All right, here's our first notebook. You can see by default, it's called Untitled. Let's change that to Hello World. So this is going to be the Hello World of our machine learning project. Let's rename this. Now, if you look at your desktop, you can see this file, helloworld.ipynb. This is a Jupyter notebook. It's kind of similar to our Py files where we write our Python code, but it includes additional data that Jupyter uses to execute our code. So back to our notebook, let's do a print hello world. And then click this run button here. And here's the result printed in Jupyter. So we don't have to navigate back and forth between the terminal window. We can see all the result right here. Next, I'm going to show you how to load a dataset from a CSV file in Jupyter. All right, in this lecture, we're going to download a dataset from a very popular website called Kaggle.com. Kaggle is basically a place to do data science projects. So the first thing you need to do is to create an account. You can sign up with Facebook, Google, or using a custom email and password. Once you sign up, then come back here on Kaggle.com. Here in the search bar, search for video game sales. This is the name of a very popular data set that we're going to use in this lecture. So here in this list, you can see the first item with this kind of reddish icon. So let's go with that. As you can see, this data set includes the sales data for more than 16,000 video games. On this page, you can see the description of various columns in this data set. We have rank, name, platform, year, and so on. So here's our data source. It's a CSV file called vgsales.csv. As you can see, there are over 16,000 rows and 11 columns in this data set. Right below that, you can see the first few records of this data set. So here's our first record. The ranking for this game is 1. It's the Wii Sports game for Wii as the platform, and it was released in year 2006. Now, what I want you to do is to go ahead and download this data set. And as I told you before, you need to sign in before you can download this. So this will give you a zip file, as you can see here. Here's our CSV file. Now I want you to put this right next to your Jupyter notebook. On my machine, that is on my desktop. So I'm going to drag and drop this onto the desktop folder. Now, if you look at the desktop, you can see here's my Jupyter Hello World notebook, and right next to that we have vgsales.csv. With that, we go back to our Jupyter notebook. Let's remove the first line and instead import pandas as PD. With this, we're importing pandas module and renaming it to PD, so we don't have to type pandas dot several times in this code. Now let's type PD dot read underline CSV and pass the name of our CSV file. That is vgsales.csv. Now, because this CSV file is in the current folder right next to our Jupyter notebook, we can easily load it. Otherwise, we'll have to supply the full path to this file. So this returns a data frame object, which is like an Excel spreadsheet. Let me show you. So we store it here, and then we can simply type df to inspect it. So one more time, let's run this program. Here's our data frame with these rows and columns. So we have rank, name, platform, and so on. Now, this data frame object has lots of attributes and methods that we're not going to cover in this tutorial. That's really beyond the scope of what we're going to do. So I leave it up to you to read Pandas documentation or follow other tutorials to learn about Pandas data frames. But in this lecture, I'm going to show you some of the most useful methods and attributes. The first one is shape. So shape, let's run this one more time. So here's the shape of this data set. We have over 16,000 records and 11 columns. Technically, this is a two-dimensional array of 16,011. Okay? Now, you can see here we have another segment for writing code. So we don't have to write all the code in the first segment. So here in the second segment, we can call one of the methods of the data frame, that is df.describe. Now, when we run this program, you can see the output for each segment right next to it. So here's our first segment. Here we have these 3 lines, and this is the output of the last line. Below that, we have our second segment. Here we're calling the describe method, and right below that, we have the output of this segment. So this is the beauty of Jupyter. We can easily visualize our data. Doing this with VS Code and terminal windows is really tedious and clunky. So what is this describe method returning? Basically, it's returning some basic information about each column in this data set. So as you saw earlier, we have columns like rank, year, and so on. These are the columns with numerical values. Now, for each column, we have the count, which is the number of records in that column. You can see our rank column has 16,598 records, whereas the year column has 16,327 records. So this shows that some of our records don't have the value for the year column. We have null values. So in a real data science or machine learning project, we'll have to use some techniques to clean up our data set. One option is to remove the records that don't have a value for the year column, or we can assign them a default value. That really depends on the project. Now, another attribute for each column is mean. So this is the average of all the values. Now, in the case of the rank column, this value doesn't really matter, but look at the year. So the average year for all these video games in our data set is 2006, and this might be important in the problem we're trying to solve. We also have standard deviation, which is a measure to quantify the amount of variation in our set of values. Below that, we have min. As an example, the minimum value for the year column is 1980. So quite often when we work with a new data set, we call the describe method to get some basic statistics about our data. Let me show you another useful attribute. So in the next segment, let's type df.values. Let's run this. As you can see, this returns a two-dimensional array. This square bracket indicates the outer array, and the second one represents the inner array. So the first element in our outer array is an array itself. These are the values in this array, which basically represent the first row in our data set. So the video game with ranking 1, which is called Wii Sports. So this was a basic overview of Pandas data frames. In the next lecture, I'm going to show you some of the useful shortcuts of Jupyter. In this lecture, I'm going to show you some of the most useful shortcuts in Jupyter. Now, the first thing I want you to pay attention to is this green bar on the left. This indicates that this cell is currently in the edit mode, so we can write code here. Now, if we press the escape key, green turns to blue, and that means this cell is currently in the command mode. So basically, the activated cell can be either in the edit mode or the command mode. Depending on the mode, we have different shortcuts. So here we're currently in the command mode. If we press H, we can see the list of all the keyboard shortcuts. Right above this list, you can see macOS modifier keys. These are the extra keys that we have on a Mac keyboard. If you're a Windows user, you're not going to see this. So as an example, here is the shape of the command key. This is Control, this is Option, and so on. With this guideline, you can easily understand the shortcut associated with each command. Let me show you. So here we have all the commands when a cell is in the command mode. For example, we have this command, open the command palette. This is exactly like the command palette that we have in VS Code. Here's a shortcut to execute this command. That is Command, Shift, and F. Okay, so here we have lots of shortcuts. Of course, you're not going to use all of them all the time, but it's good to have a quick look here to see what is available for you. With these shortcuts, you can write code much faster. So let me show you some of the most useful ones. I'm going to close this. Now, with our first cell in the command mode, I'm going to press B, and this inserts a new cell below this cell. We can also go back to our first cell, press Escape. Now the cell is in the command mode. We can insert an empty cell above this cell by pressing A. So either A or B. A for above and B for below, okay? Now, if you don't want this cell, you can press D twice to delete it, like this. Now, in this cell, I'm going to print a hello world message. So, print hello world. Now, to run the code in this cell, we can click on the run button here. So, here's our print function, and right below that, you can see the output of this function. But note that when you run a cell, this will only execute the code in that cell. In other words, the code in other cells will not be executed. Let me show you what I mean. So in the cell below this cell, I'm going to delete the call to the describe method. Instead, I'm going to print ocean. Now, I'm going to put the cursor back in this cell where we print the hello world message and run this cell. So you can see hello world is displayed here, but the cell below is still displaying the describe table, so we don't see the changes here. Now, to solve this problem, we can go to the cell menu on the top and run all cells together. This can work for small projects, but sometimes you're working with a large data set, so if you want to run all these cells together, it's going to take a lot of time. That is the reason Jupyter saves the output of each cell, so we don't have to rerun that code if it hasn't changed. So this notebook file that we have here includes our source code organized in cells, as well as the output for each cell. That is why it's different from a regular Py file where we only have the source code. Here we also have auto-completion and IntelliSense. So in this cell, let's call df data frame dot. Now, if you press tab, we can see all the attributes and methods in this object. So let's call describe. Now, with the cursor on the name of the method, we can press Shift and Tab to see this tooltip that describes what this method does and what parameter it takes. So here in front of signature, you can see the describe method. These are the parameters and their default value. And right below that, you can see the description of what this method does. In this case, it generates descriptive statistics that summarize the central tendency and so on. Similar to VS Code, we can also convert a line to comment by pressing Command and / on Mac or Control / on Windows, like this. Now this line is a comment. We can press the same shortcut one more time to remove the comment. So these were some of the most useful shortcuts in Jupyter. Now, over the next few lectures, we're going to work on a real machine learning project. But before we get there, let's delete all the cells here. So we start with only a single empty cell. So here in this cell, first I'm going to press the escape button. Now the cell is blue, so we are in the command mode, and we can delete the cell by pressing D twice. There you go. Now the next cell is activated and is in the command mode. So let's delete this as well. We have 2 more cells to delete. There you go. And the last one, like this. So now we have an empty notebook with a single cell. Over the next few lectures, we're going to work on a real machine learning project. Imagine we have an online music store. When our users sign up, we ask their age and gender, and based on their profile, we recommend various music albums they're likely to buy. So in this project, we want to use machine learning to increase sales. So we want to build a model. We feed this model with some sample data based on the existing users. Our model will learn the patterns in our data, so we can ask it to make predictions. When a new user signs up, we tell our model, hey, we have a new user with this profile. What is the kind of music that this user is interested in? Our model will say jazz or hip hop or whatever. And based on that, we can make suggestions to the user. So this is the problem we're going to solve. Now back to the list of steps in a machine learning project. First, we need to import our data. Then we should prepare or clean it. Next, we select a machine learning algorithm to build a model. We train our model and ask it to make predictions. And finally, we evaluate our algorithm to see its accuracy. If it's not accurate, we either fine-tune our model or select a different algorithm. So let's focus on the first step. Head over to bit.ly/music-csv. This is a very basic CSV that I've created for this project. It's just some random made-up data. It's not real. So we have a table with 3 columns: age, gender, and genre. Gender can either be 1, which represents a male, or 0, which represents a female. Here I'm making a few assumptions. I'm assuming that men between 20 and 25 like hip-hop, men between 26 and 30 like jazz, and after the age of 30, they like classical music. For women, I'm assuming that if they're between 20 and 25, they like dance music. If they're between 26 and 30, they like acoustic music. And just like men, after the age of 30, they like classical music. Once again, this is a made-up pattern. It's not the representation of the reality. So let's go ahead and download this CSV. Click on this ... icon here and download this file. In my downloads folder, here we have this music.csv. I'm going to drag and drop this onto desktop because that's where I've stored this Hello World notebook. So I want you to put the CSV file right next to your Jupyter notebook. Now, back to our notebook, we need to read the CSV file. So just like before, first we need to import the pandas module. So import pandas as PD. And then we'll call pd.read_CSV. And the name of our file is music.csv. As you saw earlier, this returns a data frame, which is a 2-dimensional array similar to an Excel spreadsheet. So let's call that music_data. Now let's inspect this music_data to make sure we loaded everything properly. So run. So here's our data frame. Beautiful. Next, we need to prepare or clean the data. And that's the topic for the next lecture. The second step in a machine learning project is cleaning or preparing the data. And that involves tasks such as removing duplicates, null values, and so on. Now, in this particular data set, we don't have to do any kind of cleaning because we don't have any duplicates. And as you can see, all rows have values for all columns. So we don't have null values. But there is one thing we need to do. We should split this data set into 2 separate data sets. One with the first 2 columns, which we refer to as the input set, and the other with the last column, which we refer to as the output set. So when we train a model, we give it 2 separate data sets, the input set and the output set. The output set, which is in this case the genre column, contains the predictions. So we're telling our model that if we have a user who is 20 years old and is a male, they like hip hop. Once we train our model, then we give it a new input set. For example, we say, hey, we have a new user who is 21 years old and is a male. What is the genre of the music that this user probably likes? As you can see, in our input set, we don't have a sample for a 21-year-old male. So we're going to ask our model to predict that. That is the reason we need to split this data set into 2 separate sets, input and output. So back to our code. This data frame object has a method called drop. Now, if you put the cursor on the method name and press Shift and Tab, you can see this tooltip So this is the signature of this drop method. These are the parameters that we can pass here. The parameter we're going to use in this lecture is columns, which is set to none by default. With this parameter, we can specify the columns we want to drop. So in this case, we set columns to an array with one string, genre. Now, this method doesn't actually modify the original data set. In fact, it will create a new data set, but without this column. So by convention, we use a capital X to represent that data set. So capital X equals this expression. Now, let's inspect X. So as you can see, our input set, or X, includes these two columns, age and gender. It doesn't have the output or predictions. Next, we need to create our output set. So once again, we start with our data frame, music data. Using square brackets, we can get all the values in a given column. In this case, genre. Once again, this returns a new data set. By convention, we use a lowercase y to represent that. So that is our output data set. Let's inspect that as well. So in this data set, we only have the predictions or the answers. So we have prepared our data. Next, we need to create a model using an algorithm. The next step is to build a model using a machine learning algorithm. There's so many algorithms out there, and each algorithm has its pros and cons in terms of the performance and accuracy. In this lecture, we're going to use a very simple algorithm called decision tree. Now, the good news is that we don't have to explicitly program these algorithms. They're already implemented for us in a library called scikit-learn. So here on the top, from sklearn.tree, let's import the decision tree classifier. So sklearn is the package that comes with scikit-learn library. This is the most popular machine learning library in Python. In this package, we have a module called tree, and in this module, we have a class called decision tree classifier. This class implements the decision tree algorithm. Okay, so now we need to create a new instance of this class. So at the end, let's create an object called model and set it to a new instance of decision tree classifier, like this. So now we have a model. Next, we need to train it so it learns patterns in the data. And that is pretty easy. We call model.fit. This method takes two data sets, the input set and the output set. So they are capital X and Y. Now finally, we need to ask our model to make a prediction. So we can ask it, what is the kind of music that a 21-year-old male likes? Now, before we do that, let's temporarily inspect our initial data set, that is music data. So look what we got here. As I told you earlier, I've assumed that men between 20 and 25 like hip-hop music. But here we only have 3 samples for men aged 20, 23, and 25. We don't have a sample for a 21-year-old male. So if you ask our model to predict the kind of music that a 21-year-old male likes, we expect it to say hip-hop. Similarly, I've assumed that women between 20 and 25 like dance music, but we don't have a sample for a 22-year-old female. So once again, if you ask our model to predict the kind of music that a 22-year-old woman likes, we expect it to say dance. So with these assumptions, let's go ahead and ask our model to make predictions. So let's remove the last line. And instead, we're going to call model.predict. This method takes a 2-dimensional array. So here's the outer array. In this array, each element is an array. So I'm going to pass another array here. And in this array, I'm going to pass a new input set, a 21-year-old male. So 21, 1. That is like a new record in this table. Okay, so this is one input set. Let's pass another input set for a 22-year-old female. So here's another array. Here we add 22, 0. So we're asking our model to make 2 predictions at the same time. We get the result and store it in a variable called predictions. And finally, let's inspect that in our notebook. Run. Look what we got. Our model is saying that a 21-year-old male likes hip hop and a 22-year-old female likes dance music. So our model could successfully make predictions here. Beautiful. But wait a second. Building a model that makes predictions accurately is not always that easy. As I told you earlier, after we build a model, we need to measure its accuracy. And if it's not accurate enough, we should either fine-tune it or build a model using a different algorithm. So in the next lecture, I'm going to show you how to measure the accuracy of a model. In this lecture, I'm going to show you how to measure the accuracy of your models. Now, in order to do so, first we need to split our data set into two sets, one for training and the other for testing. Because right now, we're passing the entire data set for training the model, and we're using two samples for making predictions. That is not enough to calculate the accuracy of a model. A general rule of thumb is to allocate 70 to 80% of our data for training and the other 20 to 30% for testing. Then instead of passing only two samples for making predictions, we can pass the dataset we have for testing, we'll get the predictions, and then we can compare these predictions with the actual values in the test set. Based on that, we can calculate the accuracy. That's really easy. All we have to do is to import a couple of functions and call them in this code. Let me show you. So first on the top, from sklearn.model_selection module, we import a function called train test split. With this function, we can easily split our dataset into two sets for training and testing. Now, right here, after we define X and Y sets, we call this function. So train test split, we give it three arguments, X, Y, and a keyword argument that specifies the size of our test dataset. So test underline size, we set it to 0.2. So we are allocating 20% of our data for testing. Now, this function returns a tuple, so we can unpack it into four variables right here. X underline train, X underline test, Y underline train, and Y underline test. So the first two variables are the input sets for training and testing, and the other are the output sets for training and testing. Now, when training our model, instead of passing the entire dataset, we want to pass only the training dataset. So X underline train and Y underline train. Also, when making predictions, instead of passing these two samples, we pass X underline test. So that is the dataset that contains input values for testing. Now we get the predictions. To calculate the accuracy, we simply have to compare these predictions with the actual values we have in our output set for testing. That is very easy. First, on the top, we need to import a function. So from sklearn.metrics, import accuracy underline score. Now at the very end, we call this function, so accuracy score, and give it two arguments, Y underline test, which contains the expected values, and predictions, which contains the actual values. Now this function returns an accuracy score between 0 to 1. So we can store it here and simply display it on the console. So let's go ahead and run this program. So the accuracy score is 1 or 100%. But if we run this one more time, we're going to see a different result, because every time we split our data set into training and test sets, we'll have different data sets, because this function randomly picks data for training and testing. Let me show you. So put the cursor in the cell. Now you can see this cell is activated. Note that if you click this button here, it will run this cell and also insert a new cell below this cell. Let me show you. So if I go to the second cell, press the escape button. Now we are in the command mode. Press D twice. Okay, now it's deleted. If we click the run button, you can see this code was executed and now we have a new cell. So if you want to run our first cell multiple times, every time we have to click this and then run it and then click again and run it. It's a little bit tedious. So I show you a shortcut. Activate the first cell and press Control and Enter. This runs the current cell without adding a new cell below it. So back here, let's run it multiple times. Okay, now look, the accuracy dropped to 0.75. It's still good, so the accuracy score here is somewhere between 75% to 100%. But let me show you something. If I change the test size from 0.2 to 0.8, so essentially we're using only 20% of our data for training this model, and we're using the other 80% for testing. Now let's see what happens when we run this cell multiple times. So Control and Enter. Look, the accuracy immediately dropped to 0.4. One more time. Now 46%, 40%, 26%. It's really, really bad. The reason this is happening is because we are using very little data for training this model. This is one of the key concepts in machine learning. The more data we give to our model and the cleaner the data is, we get the better result. So if we have duplicates, irrelevant data, or incomplete values, our model will learn bad patterns in our data. That is why it's really important to clean our data before training our model. Now, let's change this back to 0.2. Run this one more time. Okay, now the accuracy is 75%. Now it dropped to 50%. Again, the reason this is happening is because we don't have enough data. Some machine learning problems require thousands or even millions of samples to train a model. The more complex the problem is, the more data we need. For example, here we're only dealing with a table of 3 columns, but if you want to build a model to tell if a picture is a cat or a dog or a horse or a lion, we'll need millions of pictures. The more animals we want to support, the more pictures we need. In the next lecture, we're going to talk about model persistence. So this is a very basic implementation of building and training a model to make predictions. Now, to simplify things, I have removed all the code that we wrote in the last lecture for calculating the accuracy, because in this lecture, we're going to focus on a different topic. So basically, we import our data set, create a model, train it, and then ask it to make predictions. Now, this piece of code that you see here is not what we want to run every time we have a new user or every time we want to make recommendations to an existing user, because training a model can sometimes be really time consuming. In this example, we're dealing with a very small data set that has only 20 records. But in real applications, we might have a data set with thousands or millions of samples. Training a model for that might take seconds, minutes, or even hours. So that is why model persistence is important. Once in a while, we build and train our model, and then we'll save it to a file. Now, next time we want to make predictions, we simply load the model from the file and ask it to make predictions. That model is already trained. We don't need to retrain it. It's like an intelligent person. So let me show you how to do this. It's very, very easy. On the top, from sklearn.externals module, we import joblib. This joblib object has methods for saving and loading models. So after we train our model, we simply call joblib.dump and give it 2 arguments, our model and the name of the file in which we want to store this model. Let's call that music-recommender.joblib. That's all we have to do. Now, temporarily, I'm going to comment out this line. We don't want to make any predictions. We just want to store our trained model in a file. So let's run the cell with control and slash. Okay, look, in the output, we have an array that contains the name of our model file. So this is the return value of the dump method. Now back to our desktop, right next to my notebook, you can see our joblib file. This is where our model is stored. It's simply a binary file. Now back to our Jupyter notebook. As I told you before, in a real application, we don't want to train a model every time. So let's comment out these few lines. So I've selected these few lines. On Mac, we can press Command and slash, and on Windows, Control slash. Okay, these lines are commented out. Now this time, instead of dumping our model, we're going to load it. So we call the load method. We don't have the model. We simply pass the name of our model file. This returns our trained model. Now, with these 2 lines, we can simply make predictions. So earlier we assumed that men between 20 and 25 like hip-hop music. Let's print predictions and see if our model is behaving correctly or not. So Control and Enter. There you go. So this is how we persist and load models. Earlier in this section, I told you that decision trees are the easiest to understand, and that's why we started machine learning with decision trees. In this section, we're going to export our model in a visual format, so you will see how this model makes predictions. That is really, really cool. Let me show you. So, once again, I've simplified this code. So we simply import our dataset, create input and output sets, create a model, and train it. That's all we are doing. Now, I want you to follow along with me, type everything exactly as I show you in this lecture. Don't worry about what everything means. We're going to come back to it shortly. So, on the top, from sklearn, import tree. This object has a method for exporting our decision tree in a graphical format. So, after we train our model, let's call tree.export underline graph viz. Now, here are a few arguments we need to pass. The first argument is our model. The second is the name of the output file. So here we're going to use keyword arguments because this method takes so many parameters, and we want to selectively pass keyword arguments without worrying about their order. So the parameter we're going to set is out underline file. Let's set this to music-recommender.dot. This is the dot format, which is a graph description language. You'll see that shortly. Now, the other parameter we want to set is feature underline names. We set this to an array of 2 strings, age and gender. These are the features or the columns of our data set. So they are the properties or features of our data, okay? The other parameter is class names. So class underline names. We should set this to the list of classes or labels we have in our output dataset, like hip hop, jazz, classical, and so on. So this Y dataset includes all the genres or all the classes of our data, but they're repeated a few times in this dataset. So here we call y.unique. This returns the unique list of classes. Now we should sort this alphabetically. So we call the sorted function and pass the result of y.unique. The next parameter is label. We set this to a string all. Once again, don't worry about the details of these parameters. We're going to come back to this shortly. So set label to all, then round it to true, and finally filled to true. So this is the end result. Now let's run this cell using Control and Enter. Okay. Here we have a new file, music recommender dot. That's a little bit funny. So we want to open this file with VS Code. So drag and drop this into a VS Code window. Okay, here's the dot format. It's a textual language for describing graphs. Now to visualize this graph, we need to install an extension in VS Code. So on the left side, click the extensions panel and search for dot. Look at this second extension here, GraphViz or dot language by Stefan VS. Go ahead and install this extension and then reload VS Code. Once you do that, you can visualize this dot file. So let me close this tab. All right. Look at this dot here on the right side. Click this. You should have a new menu. Open preview to the side. So click that. All right. Here's the visualization of our decision tree. Let's close the dot file. There you go. This is exactly how our model makes predictions. So we have this binary tree, which means every node can have a maximum of 2 children. On top of each node, we have a condition. If this condition is true, we go to the child node on the left side. Otherwise, we go to the child node on the right side. So let's see what's happening here. The first condition is age less than or equal to 30.5. If this condition is false, that means that user is 30 years or older. So the genre of the music that they're interested in is classical. So here we're classifying people based on their profile. That is the reason we have the word class here. So a user who is 30 years or older belongs to the class of classical, or people who like classical music. Now, what if this condition is true? That means that user is younger than 30. So now we check the gender. If it's less than 0.5, which basically means if it equals to 0, then we're dealing with a female. So we go to the child node here. Now, once again, we have another condition. So we're dealing with a female who is younger than 30. Once again, we need to check their age. So is the age less than 25.5? If that's the case, then that user likes dance music. Otherwise, they like acoustic music. So this is the decision tree that our model uses to make predictions. Now, if you're wondering why we have these floating point numbers like 25.5, these are basically the rules that our model generates based on the patterns that it finds in our data set. As we give our model more data, these rules will change, so they're not always the same. Also, the more columns or more features we have, our decision tree is going to get more complex. Currently, we have only 2 features, age and gender. Now back to our code, let me quickly explain the meaning of all these parameters. We set filled to true, so each box or each node is filled with a color. We set rounded to true, so they have rounded corners. We set labeled to all, so every node has labels that we can read. We set class names to the unique list of genres, and that's for displaying the class for each node right here. And we set feature names to age and gender, so we can see the rules in our nodes. So that was a short and sweet introduction to machine learning. Now you can use the materials that you learned in this section and apply them to solve a different set of problems. Now here's a question for you. What ideas do you have for machine learning? What kind of problems do you want to solve with machine learning? Use the comment box below and let me know. I love to hear about your ideas. Next, we're going to use Python and a popular framework called Django to build a web application. Are you ready? Let's get started. In this tutorial, I'm going to show you how to create your first website with Python and a very popular framework called Django. So it's spelled with a silent D and it's pronounced Django. It's a web framework for perfectionists with deadlines. So if you're a perfectionist and you want to quickly put together a website that is fast, scalable, and secure, Django is your best friend. And here are the popular websites built with Django, like Instagram, Spotify, YouTube, Washington Post, and so on. Now you might ask, what is a framework and why do we need a framework to build a web application or a website? Well, a framework is essentially a library of reusable modules. These modules provide functionality for common tasks. For example, in case of a web framework like Django, we have modules to work with HTTP requests, URLs, sessions, cookies, and so on. These are the concerns of pretty much every website or web application out there. So all this functionality is already baked into Django. We don't have to code it from scratch. That is why we use a framework like Django. Now, technically a framework is more than a library. So apart from providing these modules, it also defines a structure for our application. It tells us what folders and files we should have in our project. So this provides a consistency amongst various Django projects. So as you move from one company to another and work on different projects, you can easily transition from one project to another because all these applications follow the same structure. Now, with that introduction, let's create our first Django project. So back to PyCharm, close the Hello World project and create a new project. Okay, let's call this new project PyShop. Go ahead. All right, now down the bottom, let's open up a terminal window. In this window, we're going to install Django. So we use pip to install Django, but be sure to add 2 equal signs here, followed by 2.1. With this, we're telling pip that we want to install Django version 2.1. The reason I'm doing this is because in the future, when you're watching this video, chances are there is a newer version of Django out there. I want to make sure that you can easily follow these tutorials, even though what I'm going to show you in these tutorials will most likely work with the latest version of Django. I just want to be on the safe side. So let's go ahead with this. All right, Django is installed. Next, we need to create a Django project. So here, press Ctrl and L. This cleans up our terminal window. You don't have to do it, but it's just easier to see. To create a Django project, we need to execute this command, Django-admin space start project space. We're going to call this project PyShop space period. So when we install Django, Django brings a command line utility called Django admin. So this is a utility or program that we can execute from the command line or terminal right here. Now, this program takes various arguments. In this case, we want to use this argument, start project. With this, we're going to create a project called PyShop in the current folder. So this period is important here. That means the current folder. If you don't add this period, this utility is going to create an extra folder, and that looks a little bit repetitive. So let's go ahead with this. All right. Now, back to the project panel. If you expand PyShop, you can see that this is our project that we created in PyCharm. And in this folder, we have these files. So init.py, you have seen this before. That means this folder is a package. So we can import various modules from this package into other modules. So here we have this settings module. In this module, we define various settings for our application. You're going to see this later in this course. We also have the URLs module. And with this module, we define what should the user see when they go to, let's say, /about, /contact, /products, /shopping cart. Again, we're going to work with this soon. And finally, we have this module, WSGI, that is short for Web Server Gateway Interface. The purpose of this module is to provide a standard interface between applications built with Django and web servers. This is an advanced topic, so for now, don't worry about it. Now, outside of this folder, we also have this new file in our project, that is manage.py. As the name implies, we use this module to manage this Django project. With this, we can start our web server, we can work with our database. Again, we're going to work with this soon. So let's open up the terminal window one more time. Now type out this command, Python if you're on Windows, or Python 3 if you're on Mac, because as I told you at the beginning of the course, Mac by default comes with an installation of Python, that is Python 2. But in this course, we're using Python 3. So Python 3 space manage.py space run server. What is going on here? So with Python interpreter, we are running this program manage.py and passing run server as an argument. This manage.py is essentially the same program that we worked with here, Django admin. But we used Django admin before creating a Django project. Now we have a Django project. So in this project, we worked with manage.py. This is a module that contains some Python code. So we use this module to manage our Django project. So let's go ahead and run our development web server. As you can see, this started a development web server at this address, http://127.0.0.1. That is the address of your current machine. Now note that after this, we have :8000. Unfortunately, the link below this address has a problem. As you can see, the port is excluded. So if we click this, it opens up our web browser and points it to this address. So we don't have the port number. Let's add :8000 at the end. And here's our first Django website. So we created this Django project. Now this Django project can contain multiple apps. These apps don't represent the entire application. There are small functional areas in our Django project. Here's an example. Imagine you want to build a website or a web application like Amazon. Amazon is a big website. It has so many different functions. Instead of implementing all these functions in a Django project, we divide this project into small functional areas that are focused on one concern. For example, we could have functional areas like product management, order management, customer management. These are completely different functional areas. The functions we have for managing the customers are different from the functions for managing the products. By the same token, when you go to an organization, there are small departments or small offices specializing in different areas. So with this analogy, we divide a Django project into multiple Django apps. Each app is focused on one functional area. So in this tutorial, I'm going to show you how to add a new app to manage the products in our imaginary shop. In the future, let's say we want to add a blog to our online shop. We could come back here and create a new app that represents a blog. Now, the beauty of these apps is that we can reuse them across different Django projects because each app is essentially a Python package. Let me show you. So back to our project, let's open up a terminal window. So this is the terminal window we opened earlier where we started our web server. Now up here, we have this plus button for creating a new terminal window. So let's click that. Now let's type out this command. Python on Windows or Python 3 on Mac, manage.py. So we are using the same program, the same module, but this time with a different argument. Start app, and we're going to call that app products. Let's go ahead. All right, now here we have a new folder called products. Let's see what we have in this folder. We have a subfolder called migrations. We'll look at this later. Below that, we have this init.py. So products is a package. We can take this package and reuse it in another Django application, or more specifically, Django project. We can also publish this package to PyPI for other people to reuse in their Django projects. For example, if someone else wants to build an online shop, they can reuse this package for managing the list of products. They don't have to build this functionality from scratch, okay? We have this module, admin, and this is used for defining how the administrative panel of this app will look like. Again, we're going to come back to this later. Below that, we have this module, apps. Unfortunately, the name is a little bit confusing because right now we are inside of one app, that is the products app, and it doesn't make sense to have a module called apps inside of an app. So I don't know why Django creators decided to call this module apps, but basically we use this module to store various configuration settings for this app. So it would be better to call this config. But that aside, let's move on. Next, we have models, and this is where we define classes or new types for modeling the concepts in this app, in this domain. For example, in the domain of products, you probably have concepts like product, category, review, and so on. So we could model these concepts using classes. Again, we're going to come back to this and define a new class here. Next, we have tests.py, and this is where we write automated tests for this app. That's an advanced topic beyond the scope of this course, so don't worry about it. And finally, we have the views module. And this is where we define what should the user see when they navigate to a certain page. In this tutorial, I'm going to show you how to create your first view or view function in Django. What is a view function? A view function is basically a function that gets called by Django when the user navigates to a particular page. For example, here we are on the homepage of our website. When we go to /products, our browser sends an HTTP request to our web server. At this point, Django takes that request, it inspects the URL or the address, it figures out that we want to see the list of products. Then it will call a function, which we call a view function, and the job of this function is to return the response to the browser or to the client. So this function should generate some HTML markup to be returned to the client. Our browser will get this HTML content and display it as a page right here. Now, technically, if you want to be a web developer, you need to know HTML, CSS, and JavaScript. I'll try to do my best to hold your hand throughout this course. But in the future, be sure to watch a tutorial about HTML, CSS, and JavaScript. On my channel, I have plenty of JavaScript tutorials. I recommend you to start with my JavaScript tutorial for beginners. So back to our project. Inside the products app, let's open up the views module. So here on the top, we have some boilerplate code. From Django.shortcuts, we are importing the render function. So Django is a package, shortcuts is a module, and we are importing the render function. You will see this soon. Below that, we have this comment. We don't need it. Let's create our first view function. So define. We call this function index. It doesn't really matter, but by convention, we use the word index for the main page of an app. So when we go to /products, this will be the main page of our products app. Now, potentially in the future, we could support additional URLs inside of this app. For example, products/new or trending and so on. So we call this function index. Now, all our view functions should always take a parameter, and that is the HTTP request that is passed to this view function. So as I told you before, when we navigate to /products, our browser sends an HTTP request to our web server. Django takes this request and sends it to our view function. With this request object, we can find information about the client. Now, in this tutorial, we don't want to worry about HTML. We just want to return some plain text to the browser, like hello world. So on the top, from Django.http module, we need to import a class called HTTP response. With this class, we can create an HTTP response to return to the client or the browser. So back to our view function. Here we return an HTTP response object. So we're creating an instance of this class, right? Now, as an argument to the constructor, we pass hello world. Now we need to add an extra blank line above the index function to make PyCharm happy. Beautiful. As simple as that. So we are done with this view function, but nowhere Django knows that it should call this function when we send a request to /products. So we need to tell Django that, hey, whenever there is a request to /products, call this index function. We need to map this URL to this function. A URL is short for Uniform Resource Locator, and that basically means address. Okay, so let's do the mapping. We're done with this module, close it. Back to our products app, right-click this folder and add a new Python file. Call that URLs. The name is very important here. This is one of the conventions that Django framework defines. So we need to follow this convention to structure our project. Okay, so this adds urls.py inside of the products app. Now in this module, once again, by convention, we should define a variable called URL patterns. Make sure to spell it exactly as you see here. So there is no underscore between these two words, and all characters are in lowercase. So we set this to a list object. In this list, we map various URLs to their view functions. Now to reference a URL, we need to import the path function. So on the top, from Django.urls, let's import the path function. With this function, we can map a URL to a view function. So we call the path function. The first argument is a string that specifies our URL endpoint. Here we pass an empty string that is a string with no characters in it. And this represents the root of this app. Let me show you what I mean. So imagine our app starts at /products. So if the user sends a request to this endpoint, they will be at the root of this app. Potentially here we could have other URLs like /products, /one, /detail, or /products, /new, or trending, or whatever. So all the URLs in this app start with /products. Okay, now back to the first example. What happens if we take away this /products? We're left with nothing. And that is why we use an empty string here. Now, as the second argument to this function, we need to specify our view function. So we defined that view function inside of the views module. So first we need to import this module into the URLs module. Now, this is how we do this. From period import views. Period means the current folder. So from the current folder, we are importing the views module. So with this syntax, we're telling Django to import the views module that we have in this folder. Now you might ask, Mosh, why didn't we import the views module like this? Import views, because views is actually in the current folder. So why do we have to use the from import syntax? The reason for this is because views is kind of a generic name. So it is possible that our project has a dependency to another library called views. With this syntax, Python will end up importing that module instead of the views module in the current folder because that will take priority. So to remove these potential issues, we use the from import syntax. So now we imported the views module. As you know, when we import a module, that module will end up being an object. So we can use the dot operator to access the functions defined in that module. So here we want to reference the index function. Okay, let's delete it from here. Back to our path function. As the second argument, we type out views.index. Now note that I'm not calling this function. I'm simply passing a reference to it. Django will take care of calling this function at runtime when the client sends an HTTP request to the server. So here we should not call this function. So let's quickly recap what we have done up to this point. In the views module, we created this view function. And in this view function, we simply return some plain text to the browser or the client. Now, I told you that nowhere Django knows that it should call this function. So that's why we added the URLs module to our app. And in this module, we mapped the root URL to this view function. There's one more step left. We need to tell Django about this app because up to this point, Django is not aware of this app. So let's collapse the products folder and open up the PyShop folder. In this folder, we have another URLs module, and this is like the root or the parent URLs module in our Django project. Let's open this and scroll down. Once again, you see this URL patterns variable that is set to a list. In this list, again, we're calling the pass function. As the first argument, we're telling Django that, hey, any URLs that start with admin, delegate them to the admin app. So every Django project by default comes with this admin app, which gives us a beautiful administrative panel. We're going to work with that soon. So in this module, we should also tell Django about our products app. So let's add another object to this list. Once again, we call the path function. Now we tell Django that, hey, any paths or any URLs that start with products / delegate them to the products app. So we want Django to delegate the handling of that request to this URLs module that we defined in the products app. Okay? How do we do that? Very easy. Back to the main or the parent URLs module. On line 16, we have this import statement. Let's expand it. So basically, we have two import statements. Look at the second one. From Django.urls module, we're importing the pass function. There is another function that we need to import, and that is the include function. Now we're going to use this function on line 21. So as the second argument to the pass function, we call include. And here we need to reference the URLs module in the products app. So we type out products.urls. So take a look. In the products app, you have this module, URLs. That is why we type products.urls. But we don't type out .py. Django will automatically take care of that. Now, at this point, you might be a little bit confused or intimidated by all these various steps that you have to follow. They may look foreign to you, but trust me, this becomes second nature as you practice building Django applications. It's actually very easy. It's just the first time that you have to follow these conventions defined in Django framework. Once you understand the concept, it becomes really easy. So basically, because we created a new app, the products app, only once ever, we need to write this line of code to tell Django that, hey, any URLs that start with products / send them to the URLs module in the products app. So we write this line of code only once. Anytime in the future, we want to define a new view function. First, we go to the views module, we create a new function, and then we go to the URLs module in that app and define a new URL pattern to map that view function to a URL endpoint. That is really easy. All right, now let's test our application. So back to the browser, let's head over to /products. There you go. You see our hello world message here, beautiful. But if we navigate back to the home page, we get this error, page not found. So our beautiful Django homepage disappeared. And the reason for this is that that homepage is automatically generated and is only displayed when we first create a Django project. As soon as we define a new URL pattern and register it in our project, that homepage disappears. But don't worry, we're going to come back and create a new function for our homepage later in the course. Now here's your exercise. I want you to modify this Django project such that when we navigate to products/new, we'll see a page here with some text like new products. I strongly encourage you to do this exercise because it makes it really easy for you to follow the future tutorials. All right, here in the products app, let's open up the views module. In this module, we define a new view function. So define, let's call that function new. As I told you before, every view function should take this request parameter. Now here we want to return an HTTP response with the text new products. That's it. Now to make PyCharm happy, we add another line break here. So we have 2 line breaks after the index function and also 2 line breaks after the new function. These are the best practices defined in PEP 8 to format our code. So we're done with this view function. Now we need to map it to a URL endpoint. So we go back to the products app and open up the URLs module. Here we need to add another URL pattern. So we call the path function. The first argument should be new. You want to map this URL endpoint to views.new function. That's all you had to do. Now back to our browser. When we navigate to products/new, we get this message in the browser. Beautiful. In this tutorial, I'm going to show you how to create a model in a Django project. A model is a representation of a real-world concept. For example, in an online shop, we could have models like order, customer, shopping cart, product, review, and so on. So let's go ahead and create our first model. Here in the Products app, open up the Models module. In this module, we're going to create a new class called Product. So let's delete this comment. We don't really need it. Class, Product. Now we need to inherit this class from the model class in Django. So in parentheses, we type out models.model. Let's see what's going on here. So on line 1, from Django.db package, we are importing the models module. In this module, we have a class called model, and this class defines all the common characteristics and behavior for models in a Django application. For example, we want to be able to store these models in a database, or read them from a database, or delete them. These are all the common operations that we need to perform on these model objects. So by inheriting this product class from this model class, our product class will have all these capabilities built into it. We don't have to code it, okay? So, colon. Now in this class, we need to define a few attributes. What are the attributes of a product that we need to know in an online shop? We need to know their name, price, stock, image, and so on. So let's define a new attribute. We call it name, and we set it to an instance of models, the charField class. So once again, in this module, we have a class called charField, which is short for character field, and this represents a field that can contain textual data. Now here, as a best practice, we can supply a maximum length to prevent a malicious user or hacker from accidentally storing a product with an enormously large name. This can mess up with our application. So let's pass a keyword argument, max length, and we set it to 255 characters. Now let's define the price attribute. So we set price to models dot float field. So this represents a field that can contain floating point numbers. That's it. Now let's define the stock. We set this to an instance of models.integer field. And finally, let's define image underline URL to an instance of models.once again charField. So in this course, we're going to use Google to find an image for our products. For example, we can find this image, right-click it, and copy its link address, which is the URL. Now, if you open up a new tab and paste that URL, you can see this is a very long string. So we don't want to enforce a maximum length of 255 characters. Instead, we want to use 2083 characters. That is the standard maximum length for URLs. So our product class or product model has these 4 attributes. Now to make PyCharm happy and remove this warning, let's put the cursor at the end of this line, press enter, then backspace to remove the indentation. Beautiful. We should also add 2 line breaks before this class. So here's one, press enter, the second line break. Beautiful. So our code is formatted according to PEP 8 standards. Next, I will show you how to use this model to create a database table for storing products. In this Django project we have created, you can see we have this file db.sqlite3. This is an empty database file that Django creates, and we use this to store our data. Now, SQLite is a kind of database, and it's the simplest for small applications, but it's not suitable for large enterprise web applications. So if you want to build a real enterprise web application with Django, you need to use a proper database engine like SQL Server, MySQL, Oracle, Postgres, and so on. The good news is that Django supports all of these database engines, but SQLite is the easiest to get started. So we're going to work with this for now, and in the future, I will show you how to use a proper database engine. Now, for the purpose of this tutorial, I want you to open up your browser and search for DB browser for SQLite. So on this page, sqlitebrowser.org, you can find a very simple and free application for opening SQLite databases. And as you can see here on the right side, there are executables for Windows, Mac, and so on. So when you open it, you get something like this. We can create a new database here on the top or open an existing one. Now here I'm going to drag and drop our database file right here, you can see we don't have any tables in this database. So to store data, first we need to create a table. For example, to store the list of products, we need to create the table called products, and the fields or columns we have in this table should be exactly the same as the attributes we have in our product class. So in this tutorial, I'm going to show you how to use Django to automatically create this table. We don't have to do this by hand. We can just tell Django, hey, here's our model. Go ahead and automatically create a database table for storing our products. That is very easy. So here down the bottom, let's open up a new terminal window and run Python on Windows or Python 3 on Mac, manage.py, make migrations. Make sure to spell this properly. So make migrations in one word. Now when you run this, you get this message, no changes detected, because by default, Django doesn't know about our product model. To solve this problem, we need to go back to our project and open the PyShop package. In this package, we have this settings module for storing various configuration settings for our project. So let's open this and scroll down. On line 33, you can see a variable called installed apps set to a list of strings. These are applications or apps that are automatically installed with every Django project. For example, we have this admin app, which gives us a beautiful administrative panel. You're going to work with it soon. We also have this auth app, and we use this to authenticate users. You can put them in different roles, give them different permissions. It's all about authentication and authorization. We'll look at the other installed apps in a future tutorial. So for now, let's register our products app in this list. How do we do that? First, we go to our project. Inside the products app, earlier I told you about the apps module. Take a look here. The name of this module is a little bit misleading because we're in the boundary of one app and we have a module called apps. That aside, all we have here is a class called products config where we store configuration settings for this particular app. Okay? Now we need to go back to our settings module and add the complete path to this class, including its package and module. So this class is defined in the apps module, and this module is inside of the products package. So back to the settings file. In the list of installed apps, we need to type out a string like this. Products, that's our package, dot, apps, that's our module, and then products config. Again, make sure to spell this properly. So P and C are capitalized because here we have a class, but products and apps are all in lowercase, okay? So now Django knows about our products app. So when we go back to the terminal and run the last command, we'll get a different result. So use the up arrow to bring up the last command and enter. There you go. Now we get this message, migrations for products. So inside the products folder, inside the migrations folder, we have a new module with this sequence number called initial. Let's have a quick look at the code inside this module. So back to our products app, let's expand the migrations folder. Here's our initial migration. Let's have a quick look here. So we have a class called migration. And in this class, we have this attribute called operations, which is set to a list of operations. So every migration can contain multiple operations. Look at the first operation we have here, migrations that create model. So with this operation, we can create a new database table called product. And in that table, we're going to have these fields, ID, name, price, stock, and image URL. These are the attributes that we created in our product class. But we didn't have this ID attribute. Django automatically generates this because every database table must have an ID field. And we use this to uniquely identify records in our database. Now, let's go back to the terminal. So we have a new migration, but our database is still in its previous state. We don't have a new table here yet. So we need to run this new migration to generate our product table. And that is very easy. So one more time, Python, manage.py, migrate. When we run this command, Django will look at our project. It will look at every app and it will run the pending migrations for that app against our database. So take a look. When we run this, we get several messages. So if you scroll up, you can see applying content types .001 initial. So in the content types app, which is one of the apps installed by default, we have this migration. So Django ran this migration and this created a database table for this app. Similarly, in the auth app, which is used for authenticating users, we have this initial migration. We also have a bunch of migrations for the admin app. So Django ran all of these migrations, and down the bottom, you can see applying products initial migration. So every app can contain multiple migrations, and each migration will make a slight change to the database to add a new table or modify an existing one. So back to DB browser for SQLite. Let's drag and drop our database file one more time here to reload it. There you go. Now we have 12 tables in this database. Each table is prefixed with the app it belongs to. For example, you can see we have a table for storing our users. We have another table for storing the groups a user belongs to. We have another table for storing permissions and so on. Now here down the bottom, you can see this table, products, underline product. So this product table is prefixed with the name of our app, which is products. Now, if you expand this, you can see these fields in this table: ID, name, price, stock, and image URL. So this is the beauty of Django. We didn't have to come here and manually create these tables by hand. That's very time consuming. We simply created a model with these attributes, and then we ran two commands in the terminal. One for creating a new migration based on the changes we have made in our code, and the other to run the pending migrations. So now all the migrations in this project are run against our database, which means if we go back to the terminal and run python manage.py migrate, we get this new message: no migrations to apply. So here's the workflow. Next time we create a new model or modify an existing one, we should come back here in the terminal, create a new migration, and then run it. All right, here's your exercise. We want to have the concept of offering discounts in our imaginary online shop. So I want you to create a new model class called offer. And in this class, we should have three attributes. One is code, which is a textual field. For example, our offers code could be VCA2142. It's just a coupon code. Here we should also have an attribute called description. Again, this is going to be a textual field. For example, we can say 20% off all products. And then we can display this text somewhere on the homepage in the future. And finally, we need another attribute called discount, which is going to be a floating point number, like 0.2 for 20% discount. So go ahead, create this model class. Next, create a migration and run it to bring our database up to date. This is an awesome exercise for you to get your hands dirty in Django. So spend 3 to 5 minutes on this exercise. When you're done, come back, see my solution. So here in the models module, right after our product class, I'm going to define a new class. Class offer. This class should also derive from the model class in Django. Here we add the attributes. So the first one is code, which is going to be an instance of models.char field. And we set the max length to, let's say, 10 characters. Next, we add the description. Once again, we're going to have a char field with max length of 255 characters is sufficient. And finally, we need discount. And we're going to set this to an instance of models.float field. So here's our offer class. Now we need to create a migration. So over here, I'm going to open up a terminal window. This is the main terminal window where our web server is running. So I'm going to create a new terminal window and run python manage.py make migrations. Django detected a change in our models, so it created this new migration number 2 called offer. And this migration will create the offer table in our database. So let's go ahead and run it. Python 3 manage.py migrate. Beautiful. Now let's drag and drop our database here one more time. Our database is refreshed. As you can see, in the products app, we have this new table, offer, with these 4 columns: ID, code, description, and discount. In this tutorial, I'm going to talk to you guys about the administrative panel of Django applications. So here in the browser, if we head over to /admin, we get this beautiful login screen to log into our administrative panel. So every Django application by default comes with an administrative panel. We don't have to create this from scratch. We don't have to code this. It gets auto-generated. And this is one of the fantastic features of Django that increases your productivity. So let me show you how to work with this administrative panel. Here in PyCharm, we need to create the first user of this application. We call that super user. So here in the terminal window, let's run Python manage.py create super user, all in one word. So let's go ahead with that. It asks for a username. Let's type admin. Next, we need to enter an email address. I'm going to enter my email address. Next, we need to enter a password. I'm going to type 1234 and repeat it one more time. Note that it complains because this password is too short, it's too common, and it's entirely numeric. So at the end, it asks if you want to bypass password validation. For simplicity, let's go with that. But of course, in a real scenario, you don't want to create an admin user with such a simple password. All right, we successfully created the super user. Now back in the browser, let's log in with admin and 1234. There you go. So this is our administrative panel. As you can see, we can manage the users and groups. We can add new users or modify or delete existing ones. Let's have a quick look here. So here we have this search bar on the top. We can quickly search for users. Below that, we have this table of users with these columns: username, email, first name, last name, and status. We can sort this table by any of these columns. We also have these filters on the right side. So we get all these beautiful features for free with every Django application. We don't have to code this. Earlier in this course, we talked about this settings module. Let's have a quick look here. In this module, we have a setting or a variable called installed apps. And one of the apps that is installed by default is the admin app. So this app is the piece that is responsible for generating these views. Now, the beautiful thing about the admin app is that it is easily extensible. So back to the home page of our administrative panel, so far we can only manage the users and groups. But using one line of code, we can also manage our products. Let me show you. Let's expand our products app. Inside of this app, we have this module admin. And in this module, we register the models that we need to manage in the admin section. So let's open this module. Now on the top, first we need to import our product model. So we can type out some code like this from period models. That means the models module in the current folder. So from this module, we want to import the product class or the product model, right? Now you can see this comment here, register your models here. Let's delete this comment. We don't need it anymore. Instead, we're going to write code like this. So admin.site.register, and we pass this product class as an argument. What is going on here? We're using this admin object that is imported on line 1. This object has an attribute called site, which is an object itself. This object has a method called register. We're calling this method and passing our product class as an argument. With this, we're telling Django that we want to manage our products in the admin area. So now with only one line of code, or more accurately 2 lines, if we go back to our administrative panel and refresh this page, we see this new table, products, that represents our products app. And in this app, currently we only have one model called product. So here we can manage all our products. Currently, we don't have any products in our database. So let's go ahead and add a new product. Look, we get this beautiful form for free. We didn't write any code to create this form and handle the click event of these buttons to insert a product into our database. All this is automatically generated by Django. So let's go ahead and add a new product. Call that orange. Let's say 1.99 each. And set the stock to 50. Now we need an image URL. So open up a new tab here. And in Google, search for orange. Then go to images. Click on tools. From the user rights menu, select for labeled for reuse. This way we don't have problem with copyright issues. So these are the free images that we can use in our application. Let's pick this one. Click on it again. Now on this page, right-click the image, copy a link address, and then back to our product form, paste it here, and then save. So we successfully added a product And that product is listed here in the product table. But what we see here is a little bit confusing. It says product object 1. It's not clear what product this is. Is it an orange? Is it a strawberry? What price is it? So in the next tutorial, I will show you how to customize this table and add columns specific to products. In this tutorial, I'm going to show you guys how to customize this products table in the admin area. That is very easy. So back to PyCharm. Here in the admin module where we register the product class for administration, we need to create a new class called product admin. So we create a class called product admin. So this is the convention we follow in Django. We start with the name of our model, that is product, and then we add the suffix admin. Now we should inherit this class from admin.modelAdmin. What is going on here? Well, this admin is a module that we have imported on line 1. In this module, we have a class called modelAdmin, which provides all the common functionality for managing models in the admin area. So by deriving this class from the modelAdmin, this class inherits all this common functionality. Now, in the body of this class, we can override or change some of this functionality or attributes. For example, in this class, we have an attribute called list_display, and this attribute specifies the columns that should be visible in this table. So we set this to a tuple, and in this tuple, we add one or more attributes of our product class. So let's quickly open up our product class. It's here in the models module. Okay, there you go. So our product class has these attributes: name, price, stock, and image URL. Now, image URL, as you saw, is a long string, so we don't want to display that in our table. So in this tutorial, let's add these 3 attributes to our products table. Back to the admin module. In this tuple, we add 3 strings: name, price, and stock. Now we have this little warning here because we haven't added 2 line breaks before and after this class. That is better. Finally, when registering our product class for administration, as the second argument, we need to pass this new class, product admin. So Django will use the information in this class to decide how to present the list of products. So back in the browser, let's refresh this page. There you go. Here's our products table. Now we have 3 columns: name, price, and stock. You can see we have this orange. The price is set to 1.99, and currently we have 50 items in the stock. Beautiful. Let's go ahead and add a new product here. Let's say a strawberry, and the price 2.99, 30 for the stock, and finally we need an image URL. I'm going to paste this address that I just copied before recording this video. Okay, let's go ahead, save the changes. The product is added, beautiful. And now we have 2 products in our table. Now here's what I want you to do. I want you to pause the video and add a few more products to our database, somewhere around 5 to 10. In the next tutorial, I'm going to show you how to display these products to the public users of our website, because this admin panel is only visible to admins. So anonymous users or other registered users are not going to have access to this panel. Instead, they're going to go to /products. Now currently we are displaying a hello world message. We're going to change this page and display the list of our products in a beautiful grid. So pause the video and add 5 to 10 products, then come back, continue watching. Currently in the admin area, we can only manage the products in the products app. So there is no way to manage the offers. So as an exercise, add the ability to manage the offers here. When we click the offers link, we should see a table with 2 columns, code and discount. So go ahead and implement this and then create a new offer. All right, here's my solution. In the admin module of the products app, on line 2, first we need to import the offer class. Next, we create a new class called offer admin. We derive this from admin.modelAdmin. And here we set the list display attribute to a tuple with 2 items, code and discount. And finally, we need to register our offer model for administration. So admin.site.register offer and offer admin. That's it. Now, if we go back to the admin area and refresh the home page, we see the offers link here. Beautiful. Currently, we don't have any offers, so let's go ahead and add a new offer. I'm going to use a code like VCA1010. Let's say 10% off all products. And discount, I'm going to set this to 0.1. Now, technically, in a real application, this code should be unique. But that's a topic for a future tutorial, so for now, don't worry about it. Let's go ahead and save this offer. Okay, our offer is saved successfully. Beautiful. As you can see, in this table, we have two columns, code and discount. In this tutorial, I'm going to show you guys how to replace this hello world message with the list of products in our database. And that is super easy. So here in PyCharm, in the products app, let's open up the views module. Earlier I told you that in this module we define our view functions, which are functions that get called when the browser sends an HTTP request to the server. For example, when the user navigates to /products page, our browser sends an HTTP request to our Django application. Django takes that request and hands it off to this function, the index function. Now here we're simply returning a hello world message. We want to replace this with the list of products in our database. So the first step is to get the products stored in the database, and then we need to format them using some HTML template. So let's go ahead and on the top, import our product class from the models module. So from period models, import product. So we're importing the product class in the models module in the current folder. So period means the current folder. Now this product class has a bunch of useful methods for getting data from our database. For example, we can call product.objects.all, and this returns all the products we have in our database. We also have filter for filtering products. Let's say we want to get products that are more expensive than $2 or products that are out of stock. We can use the filter method. We also have the get method for getting a single product. And we also have the save method for inserting a new product or updating an existing one. Now, in this tutorial, we're going to use the all method to get all the products from our database. Then we store them here in this variable. So we have done the first step. Next, we need to create an HTML template for presenting this list of products to the user. So back to the project panel. Inside the products app, let's add a new folder, a new directory. And by convention, we should call that templates. Make sure to spell it properly because this is a special directory that Django looks at to load templates. So let's go ahead with that. Now we want to create a template for the index function. So inside of this folder, let's add a new file and call that file index.html. Now here we can write some HTML code. If you're not familiar with HTML, don't worry, just follow along with me. It's super easy to learn. So first let's type H1 and then press tab. This inserts an H1 tag into our HTML document, and we use this to display a big bold heading. So inside these tags, let's type products. Now below this H1, let's type UL and press tab. Now this inserts a UL tag, and we use this to display a list of items. Now we need to surround each item with an LI tag. So type out LI, press tab, and in between the tags, let's type item 1, then copy and paste this a couple times. So item 2 and item 3. Now, instead of item 1, item 2, and item 3, we want to display the name of our products. But before we get there, let's simply return this HTML markup to the client instead of the hello world message. So back to the views module. Here in the index function, we need to change the return statement on line 8. So we want to call the render function. This function is already imported on the top on line 2. We use this function to render a template. So let's call this function. As the first argument, we need to pass this request object that we get as an argument to this function. So let's pass the request here. As the second argument, we need to specify the name of our template. So we pass a string. What is the name of our template? That is index.html, right? Now, before going any further, let's go back to the browser and refresh this page. So instead of hello world, we see this products heading. This is the result of an H1 tag. And with UL and LI tags, we see these bullet points over here. Beautiful. Now, finally, we need to replace item 1, item 2, and item 3 with the list of our products. So back to our view function. As the third argument to the render function, we need to pass the list of products that we loaded from the database. So here we need to pass a dictionary. In this dictionary, we're going to add one key value pair. We're going to call the key products, but we could call it anything. It doesn't really matter. The value for that key should be the products object that we define on line 7. So here in our dictionary, let's add this key products, colon, and the value should be this products object. So let me break up what we have on line 8 over multiple lines so you can see it clearly. We're calling the render function with 3 arguments: the request object, the name of our template, and a dictionary that contains the data to be passed to this template. And finally, we're going to go to this template, index.html, and replace these items with our products. That is very easy. So just after the UL tag, I want you to type out a curly brace, followed by a %, a space, a % one more time, and a closing brace. This is what we call a template tag in Django. So in between these markers, we can write dynamic code. For example, we can add loops to repeat some instructions or write if statements to conditionally render some content. So here we want to write a for loop for product in products. So earlier in our view function, we passed these products here using a dictionary. Back to the view function, look, as the third argument to the render function, we passed this dictionary. This dictionary is called the context, so it provides data to be used in our templates. In this case, we have a property called products, and that is the reason we can access it here. So we are looping over these products. Now, for each product, we want to render a list item. So let's indent this item here and replace item 1 with the name of the product. So here we want to dynamically render the name attribute of this product object. To do that, we use double curly braces. So open 2 curly braces and close them, and in between them, type out product.name. So whenever we use double curly braces in a Django template, Django will evaluate the expression that we put here and render it in HTML. Now, the last step is to end this for block, because Django, unlike Python, doesn't rely on indentation to determine the scope of a block. So right after this for loop, once again, we add curly braces, a %, and type out end for. And then we close it here. Now, we no longer need these items here, so let's delete them. Now back to the browser, let's refresh our page. So instead of item 1 to 3, we see the name of the products stored in our database. Now let's take this to the next level by displaying the price of each product right next to it. So back to our template, this is where we're rendering the name of the product. After the curly braces, let's add parentheses. Now inside of the parentheses, we want to dynamically render the price of each product. So once again, we use the double curly brace syntax to render some value dynamically. That is the value of product.price, like this. Now back here, let's refresh the page. Now we can see the price of each product right here. Beautiful. We could also prefix that with a $sign. So before the curly braces, we add a $sign. And then when we refresh the page, we see the actual dollar value. So this is what I want you to take away in this tutorial. In Django templates, we have 2 special syntaxes. One is a curly brace and a %. This is called a template tag, and we use this to dynamically execute logic. So in between these template tags, we can write for loops to repeat some code, or we can use if statements to dynamically render content. The other syntax we have is the double curly brace syntax, and we use this to dynamically render values in our HTML markup. So whatever we put in between them will get evaluated and written to the HTML markup. Now, this page is pretty boring so far. In the next tutorial, I will show you how to convert these bullet points into beautiful cards. Over the next few tutorials, we're going to replace this boring list of bullet points with a beautiful modern card like this. So on the top, we're going to display the image for each product. Below that, we're going to display the title or the name of the product, as well as the price and potentially a button to add that product to a shopping cart. Now, to present something like this, we're going to use a framework called Bootstrap. It's a very popular framework for building modern and responsive applications. So head over to getbootstrap.com. On the home page, you should see something like this, and then go to the documentation. On this page, you can see how you can add this Bootstrap framework to your web applications. So if you scroll down, here you should see a starter template. So here we have some basic HTML markup. We want to bring all this HTML markup and store it in a template called base.html. So over here, you should see this copy button. Click that to copy this. Then back to PyCharm. In the project panel, inside of the templates folder, let's add a new HTML file. So a new file. We call this base.html. Now, with Command and V on Mac or Control and V on Windows, paste all this markup that we copied from Bootstrap website. Now, here on line 13, we have the body tag, and this is the container for what the user sees in a given web page. Now, in this example, we have an h1 tag for displaying a Hello World title. We want to replace this with something dynamic. So for each page in our application, we want to render something different. For example, when the user goes to the products page, over here, instead of this h1 tag, we want to render what we defined in index.html here. Okay, so back to base.html, let's delete this h1 tag. Once again, we're going to use a template tag. So curly brace, %, curly brace. Now, the template tag we're going to use is called block. And with this, we can define a block or a hole in this document. So we're going to create a block called content. You could call it anything, but here we're defining the content area of our website. So that's why we call this block content. Now, after this, once again, we need to add another template tag, and this is called end block. Now we should go to index.html. On the top, we should tell Django that we want to extend this base template, which means we're going to use all the markup defined here. And this gives our applications a modern look and feel. So back to index.html. Once again, we're going to use another template tag. This one is called extends. So extend. What are we extending? The template defined in base.html. So here we add a string base.html. Now we want to fill the block or the hole that we defined in base.html with these few lines. So once again, we add a template tag, block. What is the block that we're filling? That is the content block, right? And we close it here. So now all this markup is going to go in the content block. Now finally, we need to close this block. So after the last line, let's add another template tag and block. Now to make this code cleaner, I would prefer to select these few lines that belong to the content block and indent them like this. This is not required, but it just makes our code easier to read. So with these changes that we made in this tutorial, when Django tries to render this page, first it will look at base.html. So it will take all the markup defined in that file, and then it's going to fill this content block with the markup we have defined here. Now, if we go back to our browser and refresh this page, we're going to see something a little bit better. So refresh. You can see the fonts are changed, and there is a little bit more space in between the bullet points. Now we're ready to replace each bullet point with a Bootstrap card. And that's what I'm going to show you next. In this tutorial, I'm going to show you how to display these beautiful cards on our products page. Now note that this page is responsive. So if you view it on a small mobile device, we're going to have one card on each row, like this. And if you view this on a bigger screen, we're going to have more columns or more cards on each row. So let me show you how to build this. First, head over to getbootstrap.com, click on the documentation. Here on the left side, you can see a link called Components. On this page, you can see all the components that are defined in Bootstrap. These are the components that we can add to our web pages to make them beautiful and modern. So the component that we're going to use is called a card. Over here, you can see an example of a card. And right below that, you can see the markup that we need to use to render something like this. So let me resize the screen. Okay. On the top right corner, we have this button. Copy this markup. Now back to index.html. Instead of rendering a UL and a bunch of LIs, we want to render a bunch of divs. Because with UL and LI, we'll get bullet points, but we don't want to display bullet points here. So right below the h1 tag, type out div.row and then press tab. So this creates a div with the class row. Now in this row, we want to repeat multiple columns. So type out div.col, as in short for column, and then press tab. So we use these divs to create a layout like this. We have multiple columns in a row. Okay. Now inside of a column, we want to render a card. So now we should paste the markup for rendering a Bootstrap card. So paste that here. Now you can see our code looks a little bit ugly because it's not indented properly. So on the top, go to the code menu. Here we have this item, reformat code. And look at the shortcut that is associated with this command. So let's click that. Now our code is beautifully formatted and it's easier to read and modify. So we have a row. Inside this row, we have a column, and inside this column, we have a card. Now we're going to take our for loop and put it above this column. So for each product, we want to render a column. So scroll down and grab this line of code, cut it, and then paste it right above this column. Now we should close this for loop. So let's collapse this div below it. Okay. Now, right after this div, we want to add a template tag and type out end for. With these changes, we don't need the code from before. We don't need the UL and LI tags. So let's delete all of these. So this is the final result. Inside the content block, we should have these tags. We have an H1 on the top for the heading. Below that, we have a row. Then we have our for loop. And in each iteration, we render a column. So let's also indent this line to go inside the for loop. That's better. Now finally, we close our for loop. And after that, we close our row. With this change, if we go back to the browser and refresh, we get something like this. We're basically repeating all that static or fixed markup from Bootstrap over here. So we're not rendering the actual name or the image of each product. But that is a very easy fix. So back to our markup, let's expand this column. So here's our card. Inside this card, we have an image on line 9. Look at the source attribute of this image. We need to change this and dynamically render the image URL attribute of each product. So let's delete this. And inside the quotes, we add double curly braces to render some value. We want to render product.image underline URL, like this. Now over here on line 11, we have this text, card title. We want to replace this with the name of each product. So delete, double curly braces, and we add product.name. Next, we need to replace this text with the price of each product. So delete, here we have a paragraph tag. Inside this tag, we add double curly braces to render product.price. And just before these braces, we want to add a $sign. And the last change is the label for this button. It's called Go Somewhere. We want to change that to Add to Cart. Now back to this page, refresh. We should get something like this. Beautiful. In this tutorial, I'm going to show you a couple of techniques for improving the look and feel of this page. First, we're going to add a navigation bar on the top, and then we're going to add some padding around these elements. Currently, this product card is way too close to the left side of the screen. So we should add some padding to let this page breathe. Now, to add a navigation bar, once again, we go to the Bootstrap website, look at the documentation for the navbar component. So here's the navbar. Now, if you scroll down, you can see a typical navbar. So we can have these links. We could have a drop down. We could have a search bar. Now, this looks a little bit clunky because I've resized the screen, so it doesn't look pretty. But below that, you can see another simple navigation bar with only the brand or the name of the application. So over here, we have the markup to render this navigation bar. So let's go ahead and copy this. Now back to PyCharm, where should we add this markup? We should add it to base.html because this is supposed to be a base template for all pages in our application. So here's the opening body tag. Right below this body tag, we want to paste the markup for rendering a navigation bar. Now the code is not formatted properly. It looks clunky. So once again, go to the code menu and then reformat code. As you can see, the shortcut for Mac is Alt, Command, and L. So I'm going to use a shortcut here. There you go. That is better. So here's our navigation bar. Now let's change this text from navbar to PyShop. That's the name of our application, right? Now back to the browser. Let's refresh this page. We have this navigation bar on the top. Let's go back to PyCharm and make a slight change in the structure of our application. So here in the products app, we created the templates folder. And in this folder, currently we have two templates, the base template for our application and the template for the products page. The problem with this structure is that this base HTML is not reusable because we have added it inside the template of the products app. What if in the future we want to add another app to this project? We don't want to recreate this base.html in every app. That just doesn't make sense. So we want to reuse this across multiple apps. And that's why we need to move this outside of this folder and put it somewhere central. So in the root of our project, here we need to add a new folder called templates. So right click the project and add a new directory called templates. Now we want to go back to the products app. Inside the templates folder, we drag this base.html file and drop it into the main templates folder. Okay, good. Now our base template is somewhere central, so we can reuse it in multiple apps. However, if we go back to the browser and refresh this page, we get this error, template does not exist. If you scroll down, you can see why we get this error. So over here, you can see this red line. Let me zoom in. This error happened because Django couldn't load base.html. Now, if you scroll up, you can see the paths that Django searches for to find this template. Here's the first path, admin/templates/base.html. So Django is looking for this template inside the admin app. Here's the second path, auth/templates/base.html. So Django couldn't find it in the admin app. It thinks maybe it's in the auth app. And finally, here's the last path, products/templates/base.html. That is our products app. So what is going on here? Django is looking for this template only inside of the installed apps. But this templates folder that we created, it's not really part of any apps. It's just a standalone folder. So we need to tell Django to look inside this folder in addition to the installed apps. And that is very easy. So in the main package, PyShop, you have seen the settings file before. Let's have another look here. If you scroll up, you can see this variable, base directory. This variable is set to the complete path of where you have stored this Django project on your disk. We're going to take this directory and append templates to it. So scroll down. On line 55, you can see the configuration for loading templates. Look at the settings we have here. The first setting is backend, and this is the engine that is used to parse our templates. So all those template tags, as well as the double curly braces, this is the engine that knows how to interpret those. Look at the second setting, directories. This is set to an empty list. So here we need to reference the templates folder in this project. So let's type out os.path. So we're using the path object defined in the OS or operating system module that is imported on the top. Now this path object has a method called join. And with this, we can join multiple parts of a path. The first part is base_dir. which is the variable that I showed you earlier, it's set to the complete path of your Django project. Now we want to take this and append templates to it. That's all we had to do. So back to the browser, let's refresh the page. There you go, the problem is fixed. So now our base template is somewhere central and we can reuse it across multiple apps. Beautiful. And one last change. Currently, as you see, these items are so close to the left side of the screen. So I'm going to add some padding to make this page breathe. And that is very easy. Back to PyCharm. Here in our base template, where we define this content block, we need to wrap this with a div with the class container. This is one of the classes defined in Bootstrap that we use to define a container area in our application. This container area has some padding. So type out div.container and press tab. Okay, and then move these template tags inside of this div. That's it. Now back to the browser, let's refresh. So this is our container area. As you can see, we have some padding to the left and right side of this container area. Beautiful. So that brings us to the end of this Django tutorial in this Python course. I hope you learned a lot and thank you for watching. So that was a short and sweet introduction to Django. But Django really requires its own course, and I'm planning to create a comprehensive course on the topic in the near future. Now here's a question for you. What kind of applications do you want to build with Django? Use the comment box below and let me know. I will take your ideas into consideration as part of creating my upcoming Django course. So that brings us to the end of this course. I hope you learned a lot. Please support my hard work by liking this video and sharing it with others. And also subscribe to my channel for more tutorials like this. Thank you so much for watching and I hope to see you again soon.